Ninja Warriors, welcome to yet another power-packed session, and in today's session we are going to discuss all the concepts related PYQs related to circles. I know that circles is something which you guys were demanding from a long time and now it is happening. So circles, one shot, here we go. The complete chapter we are going to discuss along with very high frequency previous year questions. And if I talk about weightage of this particular chapter, but before weightage, for all of those who are coming for the very first time on this channel or who are attending the very first session of mine, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience in both online and offline. And I have taught and mentored more than 10,000 students, produced top all India ranks as well, got 1,000+ selection in various IITs, NITs and various other colleges as well. Okay. So if I talk about circles, the very first thing you guys ask is, ma'am, what is the weightage? What is the weightage of this particular chapter? So if I talk about weightage, let me just introduce a few more chapters: straight lines, circles, and then parabola, ellipse and hyperbola. Okay, let us understand that, let us consider this as a single unit. I already told you from 1 to 2 questions. Same in circles also, you can expect minimum 1 question from circles, and parabola, ellipse, hyperbola, you can expect 2 to 3 questions from conic section, parabola, ellipse, hyperbola. Okay, but straight lines is a foundation chapter of circles, parabola, hyperbola, ellipse and 3D geometry as well. Now circles similarly is a foundation chapter for your upcoming chapters like parabola, ellipse and hyperbola. So without doing circles, you actually cannot complete or you cannot start parabola, ellipse and hyperbola, because a lot of questions will involve concepts from circles. Okay, so if you're serious about conic section, if you're serious about coordinate geometry, straight lines and circle, these are 2 chapters whose basics should be absolutely clear to you. Okay, and this will definitely help you in your 3D geometry as well. Okay, so on this note, let's start today's session. So what we are going to cover in the whole circles chapter, let us understand. So first we will cover some equation of a circle. We'll start from here. Standard equation of circle, will start with this. Okay, basic geometric results we will cover along the session, the complete session. Okay, the basics, class 10th basics. Okay, then standard equation of circles, intercept made by a circle, then some standard notation, position of a point with respect to a circle, with respect to, then equation of tangent, director circle, common tangents, and family of circle, the condition of orthogonality, radical axis and radical center. So a lot of topics, small topics we are going to cover, and trust me, the session is going to be very fruitful and the basics are going to be cleared. That is first point, and you will get that confidence of attempting JEE main question as well as JEE advanced question after this session. Okay, all right, so are we ready with our pen and paper? Are we ready for it? Let's start with the standard equation of a circle. Okay, so standard equation of a circle looks like this. We have a circle. Let me just draw a circle. Yes, so this is your circle, right? Circle, yes, this is your circle, and this circle has a center. Okay, suppose your center is h, k, and the radius of this circle is r. Then the standard equation of circle looks like x minus h whole square plus y square is equals to r square. But you must be wondering, ma'am, but how did you get it? Very easy. You just have to apply the distance formula. So now if you're looking for equation of a circle, let's take any point on the circle x, y. This is a moving point. This is a general point, right? Now distance between h, k center and x, y, distance between x, y and h, k is what? R. So I have just applied the distance formula and clearly the distance formula is right in front of you. Okay. So you have to remember the equation of the circle. Okay. The very basic. Okay. All right. Now let us do one thing. Let us just apply this equation of circle in few very small examples. Okay. To build the basics. Now for example, A part, it has center 1, 2, radius is 5, correct? So it is going to be x minus 1 ka whole square because here h is 1 and k is 2. X minus 1 ka whole square plus y minus 2 ka whole square is equals to 5 square. As simple as that, right? Okay. B option. Now this time center is so known. H is 1, k is 3. But what about radius? Let us understand. First of all, x minus 1 ka square plus y minus 3 ka square and small r square. Now radius of this circle we can calculate again by distance formula. This is radius. Distance between center and 4, 7 will be radius. 4 minus square 3 ka square. 7 minus 3 ka square is 4 ka square. So clearly it is going to become 5 again. So the answer is x minus 1 whole square, y minus 3 whole square is equals to 5. All right, clear. Basic problems. Now another problem on our plate. In this C part, again, center is 2, 2, you can see. And this time radius is not given. This time circumference is given. Circumference of any circle is 2 pi r and which is given as 4 pi. Clearly from here, r will be equals to 2. Now this time r is 2 and h comma k is again 2, 2. Now you just apply this. X minus 2 ka whole square, y minus 2 ka whole square is equals to 2 square will be your answer. Okay. And if you want, you can just open this to get the final result. All right. Again, another very basic question to understand the standard equation of a circle. Okay. Now there is a special case. If your center lies at origin, that means in this equation, x minus h square, y minus k square is equals to r square. Your h and k both is becoming 0. That means your x square plus y square is equals to r square. Right? So 0, 0 is what? Origin. Okay. All right. Clear. Perfect. Now let us solve some problems to gain some more confidence. Okay. Equation of a circle with center 1, 3 and area 154 square units. Okay. Area is 154 square units. Area is pi r square of a circle, right? 154 is equals to 22 by 7 r square. Now, this can get cancelled out with 11. 11 2s are 22. 11 14 this. So this is okay. Clearly r square is coming out as 7 square. So r is equals to 7. So you're getting r is equals to 7. Center is 1, 3. Very easy. X minus 1 ka whole square plus y minus 3 ka whole square is equal to 7 square. So x square plus y square. From here we will minus 2x. From here we will 6y and plus 1 plus 9 equals to 49. So from here x square plus y square minus 2x minus 6y is clearly visible. Then you are having 10 minus 49 is minus 39. So clearly option D is absolutely right. Okay, if you solve it, you will get option D. I hope that this is clear. All right. Now let us move on to the next problem. Okay. All right. So next problem is having a hint for us as well. But before that, let's just read the question. The lines this and this are diameters of a circle. So let me just draw it. Okay. In conic section, in any chapter of geometry related, any chapter, one ninja tip is just draw everything which you are seeing. Okay. Which just try to visualize, and to visualize you need to draw it. So two diameters are here. So let us say diameter always passes through center of the circle. So this is one diameter. This is your second diameter. That means both the diameters will intersect at center of the circle. So if I solve these two equations, I will get center, and area is 150. If area is 154, this calculation so we have done. Pi r square is 154. So from here r will be 7. Okay, we just need to solve these two lines. 2x plus 2x minus 3y is equals to y. And we are having 3x minus 4y is equals to 7. Okay, let's solve it out. Okay, so this is 3, this is 2. Let's multiply. 6x minus 9y is equals to 5 3s are 15. 6x minus 12y is equals to 14. Subtract. So the moment you subtract, you will get 3y equals to 1. Y is coming out as 1 by 3. Okay. And 7 2s are 14. 5 3. Y, the moment you put y is equals to 1 by 3 in here, 2x minus 1 is equals to 5. X is equals to 3. So 3 comma 1 by 3 is your center. Let's go back. Let's check. Okay, 3 comma 1 by 3 will be your center. Let's check. Hold on. Let us just do it one more time. Let me just check. 3x minus 4y is equals to 7. 2x minus 3y is equals to 5. I have multiplied 3 2s are 6, 3 3s are 9, 3 5s are 15. 3 2s are 6, 4 2s are 8. Oh my god. Oops. There is some calculation mistake. Okay, no issues. So this is minus 8y. Now, if you subtract, this is going to become minus y is equals to 1. Y is coming out as minus 1. The moment you put y minus 1 in any of these equations, 2x plus 3 equals x is coming out as 1. So center will be 1 comma minus 1. Radius is 7. What are you waiting for? X minus 1 whole square plus y plus 1 whole square equals to 7 square. So x square plus y square minus 2x plus 2y. And from here is equals to 49. So clearly 47 is, so it is option C, right? Option C. Yes. Perfect. Is matching with option C, right? So what is the takeaway from this question? That whenever you get two diameters of any circle, just solve them out to get the center. Both the diameters or any two diameters of a circle intersect at center. Okay. Diameter is also known as normal of the circle, by the way. That we will understand it later on. Now we are having another question, very basic question again. Find the equation of the circle which passes through minus 1 comma 2 and 3 comma minus 2, and whose center lies on the line y equals to 2x. Okay. So now center lies on this line y equals to 2x. Suppose if I take x equals to a, so if I put x equals to a in this, I will get y is equals to 2a. That means I can assume my center, right? Center of the circle, I can assume center of the circle will be a comma 2a. Perfect. Now again, I told you that draw it. Whatever it is, draw it out. You will get the clarity. Okay. So now a comma 2a is the center which passes through point A and B. A is minus 1 comma 2 and B is 3 comma minus 2. Okay. Now distance from, let's say O is your center. So OA and radius. So that means you have to apply OA is equals to OB. Right? OA is equals to OB. OA is equals to OB. Or you can say OA square is equals to OB square. Can we do that? Definitely. So OA square. OA square, if you apply the result over here, OA square will be distance. If you want to apply the distance formula, so OA square is equals to OB square. So that is going to be A plus 1 whole square is equals to A minus 3 whole square plus 2A plus 2 whole square. Now just expand it. Get the value of A. Once you are having that value of A, that means you have the center. Once you have the center, then you can calculate radius and eventually the equation of the circle, right? Let's expand. So this is going to be A square plus 1 plus 2A plus 4A square plus 4 minus 8A is equals to A square minus 6A plus 9 plus 4A square plus 4 plus 2 to the 4, 4 to the 8A. Now let's start cancelling the terms. A square is getting cancelled out with A square. Okay. 4A square is also getting cancelled out with 4A square. Right. Now we are having on the left hand side minus 6A plus 1 will be equal to, minus 6A minus plus, so this is 6 plus 8, 14. 14A and this is actually 4 plus 1, 5. Right. So minus 8A plus 2A is minus 6A. 4 plus 1 is 5. Left hand side is sorted. Now right hand side. Minus 6A plus, okay, so this is minus 6A plus 8A, right? So this is going to be 2A. 2A and 4 plus 9 is plus 13. So if you solve it, you will get 8A is equals to minus, 8A is coming out as minus 8. So A is coming out as minus 1, right? A is coming out as minus 1. That means your center will be what? Center will be minus 1 comma minus 2. This is your center, right? Now that you have your center minus 1 comma minus 2, you can easily calculate your radius, right? OA will be your radius. So distance between minus 1 and minus 2 and distance between minus 1 and 2 will be your radius. So this is going to be 4. 4 will be your radius basically. So radius is 4. And now if you just quickly, quickly calculate the radius of this circle, radius is done. Just the equation of the circle basically. So x plus 1 whole square plus y plus 2 whole square is equals to 4 square. This will be your final equation of the circle. Got it? Yes, clear? Let us move on to now problem number B. Which passes through 2, 3 whose center lies on x-axis. Now any point on the x-axis can be taken as a, 0. Again, I have already told you that draw it right away. So now center is a, 0 lying on the x-axis. So I will draw a line as well. Okay. X-axis. Correct. Which passes through 2, 3 and whose radius is 5. Very clearly we have to apply the distance formula between center and passes through, let's say, A. So AC is 5, which is radius, right? Now AC. So this is going to be A minus 2 whole square plus 3, 25. Correct? A minus 2 whole square is equals to 25 minus 9. So A minus 2 will be equals to 16. So A minus 2 is either plus 4 or A minus 2 will be minus 4. So from here you will get A is equals to 6, or from here you will get A is equals to minus 2. So either your center is 6, 0, 6, 0, or your center will be minus 2, 0, right? So you can now write the equation of the circle accordingly. X minus 6 whole square plus y minus 0 whole square, radius is fixed, which is 5 square, or x plus 2 whole square plus y minus 0 is equals to 5 square. So there are two possibilities in this equation. Okay. All right. Clear? So possible equations are two equations. Now you can just expand them and figure out the final answer. Okay. Chalo. Now let us move on to, yes. So as I told you, these two are equations of the circle. If you expand the very first one, you will get this. If you expand this another one, you will get this. Okay, done, dusted. Shall we move on to the next topic? Now, there will be some special cases of a circle, some special scenarios. So it will be given in the question that circle touching x-axis. So if a circle is touching x-axis, that means the diagram will look like this, and the touching point is a, 0. Circle touching y-axis, 0, B. Okay. Now, circle touching x-axis at origin is okay. So origin 0, 0 pe it will touch. That means center will, in this case, center will lie on y-axis. If a circle touching x-axis at origin, then center lie on y-axis. You can see as per the diagram. Okay. So it can touch in two ways. So touching origin. So it can lie completely above x-axis, right, like this, or it can lie below x-axis as well. And same, circle touching y-axis at origin. So now x-axis will be, so center will pass through, or center will lie on x-axis this time. Okay. And obviously it can, the circle can either lie on right hand side of y or left hand side of y. Okay. So you have to imagine like that. Is there any another possibility? Because if you do not do that, you might miss on the cases and you might miss on the solutions. Okay. Chalo. Then we have circles touching both. Okay, so both the axes, if any circle is touching both the axes, so you can see that it can stay in first quadrant or in second quadrant or in third quadrant or in fourth quadrant. So these are the multiple cases which we can consider. Okay. And the last case, circle passing through origin just like this and cutting both the axes. So you have to draw like this. Okay. All right. All right. And one more very important thing. This is actually true for any curve, by the way. If any curve is passing through origin, any straight line passing through origin, tell me the equation of straight line. Y is equals to mx. There is no constant. If a circle is passing through origin, same thing. There will be no constant. The constant term will be 0 automatically. If because origin has to satisfy that curve. And if any curve passes through origin, that means 0, 0 will satisfy that curve. That means that there is no constant term. So the moment you see any equation, any curve which is having no constant term, just think about it. It is passing through origin. Okay. All right. Now let us do one visual question. Let's see how many of you are able to visualize the number of circles of given radius which touch both the axes is. Okay. So now we are looking for number of circles. Okay. Which touch both the axes. Although I have already given you the hint. Okay. So now this. So yes. Touching both the axes, right? So one circle can be like this. Can you see? Touching both the axes. All right. And now this circle is lying in the first quadrant. Now similarly, this circle is lying in second quadrant but touching both the axes. Similarly, this circle is lying in third quadrant but again touching both the axes. And the same circle can lie in fourth quadrant as well, touching both the axes. So there are four possibilities. Can you see? There are four possibilities, right? First, second, third and fourth. So 4 is absolutely right for this question. Okay, I guess this is a very easy visual question. So this question I have given you to understand that sometimes we visuals. Sometimes the number of circles of a given radius. So sometimes question says a circle touches both the axes. So we always think about first quadrant. Okay. We never think about that it can be in second quadrant, it can be in third quadrant, it can be in fourth quadrant. If you yourself limit the cases, because question has not given. Question has not mentioned na, that only in first quadrant, only in second quadrant. Why are you like limiting? Take generic cases, right? Okay. Now, let us do one question on this. Radius of the circle touching both the axes. So now, general case, obviously, every time I'm not going to draw those 4 circles. But in my mind, I will figure out, okay, there can be 2 circles. Okay. So, radius of the circle touching both the axes and passing through the point 1. So, this is your 1, 1. Right? Sorry, center to we don't know, right? Passing through 1, 1. So, this is 1, 1. And center of, by the way, okay, one very important point. Now understand. Center of this circle, which is passing through, which is actually touching both the axes. So, this and this, both will be equal. Right or wrong? Just tell me. Because both are radius. If this is R and this is also R, obviously it will be R. Distance between center and circumference is what? R. So, this point can be R, R. If it is lying in the second quadrant, so R, R, then it will be minus R, R. Minus R, minus R, and R, minus R. There will be 4 options, right? For the time being, let's take R, R, let's see. So, if R, R is this radius of the circle touching both the axes and passing through the point 1, 1. So, distance between R, R and 1, 1 can I calculate? Yes. R minus 1 whole square plus R minus 1 whole square. Distance between these two things is nothing but R square only. So, R square minus 2R plus 1 ka double is equals to R square. So, R square minus 4R and it will be plus 2 equals to 0. Now, you have to solve it out. So, R is equals to 2 plus minus square root of B square. So, this is 4 4 is 16 minus 8 upon 2. This is 4. R will be equals to 4 plus minus root 8 by 2. 4 plus minus 2 root 2 by 2. So, it is going to be 2 plus minus root 2. 2 plus minus root 2. Option A. Option A seems to be correct option. Yes? Okay. Option A seems to be correct. All right. Clear. Are we ready for the next question? Yes. Chalo. The equation of the circle touches y-axis having center this. Okay. Very important. Again, draw it. So, this is your circle touching y-axis. Okay. So, center is minus 2, minus 3. That means it is lying in the third quadrant. That is one thing. And it is touching y-axis. So, this is your y-axis. And this will be your x-axis. Right? This is how your diagram will look like. Now, just tell me one thing. That this distance, this is minus 2, minus 3. Right? Distance from this point from x coordinate abscissa is like horizontal distance, right? So, this distance is 2. That means radius is clearly 2. Okay. So, in the case of circle touching y-axis, modulus of abscissa of center is equals to radius. Okay. So, if any circle is touching y-axis, then how do you? By taking modulus of abscissa of center. Abscissa is what? X coordinate. Remember it. And again, if it is touching x-axis, then modulus of ordinate of center will be the radius. That is y coordinate. Okay. All right. And no need to remember. If your observation skills are on point, if you can just take that distance, then no need to remember. You can plot it, you can understand it. Okay. So, now you have got this x plus 2 whole square, y plus 3 whole square equals to 2 square. So, x square plus 4x plus y square plus 6x plus 4 plus 9 equals to 4. 4 cancel. X square plus y square. So, this is y. X square plus y square plus 4x plus 6y is and plus 9. Option C. Yes, clearly it is matching with option C. Okay. All right, all right. Now we are having another question. So I have brought so many questions so that your circles chapter will be crystal clear to you. The circle passes 1, minus 2 and touching the x-axis at the point 3, 0. Now this time it is touching x-axis at 3, 0. So this is how it will look like. Center, we don't know. We need to know. And the circle is passing 1, minus 2. Okay. And now we need to figure out the equation of the circle first. Equation of the circle we need to figure out. Then we can know that what all point can satisfy that circle. Directly we cannot know. Okay. So, now one thing. This is 3, 0, right? This is your y-axis. This is your x-axis. Now this point which is right above 3, 0. The horizontal distance from this point and this point will be same, and that would be 3 only. So, x coordinate of center in this case, by just looking at it, understand the geometry behind it. 3, let's say y. Or 3, k. Yeah, better. 3, k. Right? Now, distance of 3, k from 1, minus 2 and from 3, 0 will be same. Right? Yes. So, this distance and this distance will be same. This distance is what? Y coordinate. So, this is your k. This distance is your k. So, k will be equals to distance between 3, k and 1, so 3 minus 1 whole square plus k plus 2 whole square, and this is also whole square because square root is there in distance formula. It will become square on the left hand side. So, k square plus is equals to 4 plus k square plus 4 plus 4k. K square gone. Minus 8 is equals to 4k. K is coming out as minus 2. Okay. So, 3, minus 2 is the center, first of all. Understand. And what is the radius? Radius is your k. It is very obvious. Radius is k. So, k or mod k you can say. So, radius will be 2. Write down the equation x minus 3 whole square plus y plus 2 whole square equals to 2 square. Now, plug in the values and check which option is getting satisfied. 5, 2. Is it satisfying? Okay, so 5, 2 if I take, 5 if I put over here, 5 minus 3 is 4 plus 2 2s are 4. 4 is equals to 2 square. Not happening. Option A rejected. 5, 2 is not getting satisfied. Minus 5, 2, let us check. Actually, it is clear that 5, minus 2 will get satisfied. It's very obvious. 5, minus 2. So, option C we will check directly. 5, minus 2. The moment you put 5 over here, you will get 5 minus 3, 2 square 4. Minus 2, see, right? Minus 2. So, it will become 0. 4 is equals to 4. Option C is clearly satisfying this. Okay. All right. Clear. Chalo. I guess we are done with the basics. All right. Now, we have actually spent enough time with x minus h whole square plus y minus k whole square is equals to r square. Yes or no? Just open it. I am getting from this. So, I am getting x square plus y square minus I am getting 2hx minus 2ky. And I am getting a constant term, some constant. The standard equation, if you open it, is equals to 0. Okay. So, if I just write the general, remember the general second degree equation, which we studied in straight line? General second degree equation. So, general second degree equations will have how many terms? You tell me. Ma'am, it will have x square term. It will have y square term, it will have xy term, it will have x term, it will have y term, it will have constant. That's it. Any other term you can think of? No, we have covered pretty much everything. Now, if we observe our equation of circle with the general second degree equation, we can see that x square and y square coefficient are same and it is 1. Okay? But we can't generalize it, because if somebody multiply this whole equation of circle by 2 or by 4, then also it will represent circle, right? But one thing we can observe is coefficient of x square and y square should be same, and it cannot be 0. It should exist, right? First thing. Second thing is there is xy term is not there, absent. So h should be 0. That's it. So now, if you are given with a general second degree equation and you need to identify the condition of this second degree representing the circle, very simple. Coefficient of x square is equals to coefficient of y square, but it cannot be 0. Number 1 point. And your h, which is coefficient of xy, should be 0. That's it. Then it will represent a circle. Okay. Let me show you. Condition for a general second degree equation in 2 variables represent a circle is this and this. That's it. Let me tell you with the help of a question. If this equation represent a circle, then the value of a plus c is what they are looking for. Okay, ma'am. So now, again, coefficient of x square is a. It should be equals to coefficient of y square. So a to 2. Clear? Okay. Now, clearly there having xy, so c should be 0. C is 0. Simple. A plus c. So 2 plus 0. So a plus c being 2, then only it can represent the circle. Okay. If the equation px square plus 2 minus q xy plus 3y square, okay. So this equation, again, same question, represents a circle, then the values of p and q are what? Okay. So again, same thing. The coefficient of x square is p, that should be equal to coefficient of y square, that is 3. So p is equals to 3, one thing we have got. So values of p and q, if they are asking, so option A is absolutely rejected. B, C and D is what we need to consider. Next thing is that coefficient of xy should be 0. So this will be 0. If this is 0, that means q is coming out as 2. So P3, Q2 and 3, 2, option C is absolutely correct. Okay. So these type of questions you can get when not in JEE main, but the basic questions, right? To recognize whether this equation represent equation of circle or not. Okay. And now here comes, if you see, here comes the standard equation of a circle. Yes. Standard equation of a circle, if you observe that it will have x square term, y square term, then it will have x term, y term and constant. Okay. So whenever you see that expanded form of second degree equation, that means that we have actually opened the square, x minus h whole square is opened, solved. Y minus g square is solved, right? Y minus k square is equals to r square. So everything is solved, and then once you have solved it, you will get this. Now from this, how to calculate center and radius? One method will be just write it into perfect square form, write it into the standard form, and you're done. But that will require some steps, right? But in here, what we will do is, we will do with some shortcut, some trick, okay? So the moment you see x square plus y square plus 2gx plus 2fy plus c is equals to 0, you just need to look at the equation and you just need to identify the coefficient of x and coefficient of y. To calculate center, just identify coefficient of x and coefficient of y. So coefficient of x, what you need to do is take half of coefficient of x, reverse the sign, that's it. Same you have to do it with y. Okay, so in here let me just take an example. So if this is the equation and you have to find the center of the circle, how will you find? So ma'am, first of all, we need to identify the coefficient of x and coefficient of y. So ma'am, coefficient of x is -2. -2, now what you have to do is take half of it. -2 ka half will be -1 and reverse the sign, so it will be 1. So this will be x coordinate of the circle. Now what about y coordinate? -6y. So -6 is the coefficient of y. So -6 by 2, that is -3, and now reverse the sign. So ma'am, 3, 1, 3 will be the center. Okay, this is how it is done. So whenever you see this particular form, take half of the coefficient of x or y, both, and reverse the sign. First thing. Now what about radius, ma'am? So radius has very easy formula. Once you get the center, just square x coordinate, square y coordinate, and just subtract the constant c from it. Okay. G square plus f square minus c. Do not forget to take square root of it. Chalo. Let's do one thing. Let's just solve some question to get the hang of it. Center is 1, 3. You know how we have calculated. What about radius? So I have told you square root. 1 square plus 3 square minus constant. What is constant? -15. That's it. So radius will be 9 plus 1, 10 plus 15. So 25 ka root 5. Radius is coming out as 5. Okay. All right. Radius is 5. So center and radius. So center is this. Radius is 5. Okay. So are you guys ready for the question? Because I want you to do the next question. Okay. So now the next question is having some trick. Okay. Some twist. Not the trick, but twist. Centers and the radius of the following circle. But in here, please do not calculate it. Do not rush to calculate center and radius in here. First of all, you have to make the coefficient of x square and y square is equals to 1. Yes. Divide by 2. Divide this whole thing by 2. So x square plus y square minus 2x plus 4y minus 2 equals to 0. Now you can apply the same technique. Minus 2x and plus 4y. So center will be, take half of the coefficient of x. So ma'am, -2 half will be -1. Reverse the sign, +1. 4y. So 4. Take half of it. 2. Reverse the sign, -2. This is your center. Now what about radius? Square root. 1 square plus -2 square is 4. So 2 square you can simply write. Minus of, so this equation, -2. Minus constant, right? So this is going to become 1 plus 4 plus 2. 4, 5, 6, 7. So radius is coming out as √7. And your center is 1, -2. Okay. All right. Clear? Chalo. Now let us talk about this question. If the line x plus 3y is equals to a is the diameter of this circle. Okay. I always tell you that draw a circle. Now diameter is passing through center of the circle. If you know center of the circle, you can satisfy that center in this line, right? So center of the circle you can satisfy. Can you just tell me the center of the circle? Ma'am, definitely. X square plus y square minus 6x plus 2y. One very important thing is this circle has no constant, right? That means this circle is passing through origin, number 1 point. But in this case, it doesn't matter. I'm just trying to make your observation skills on point. Center will be 3, -1, right? Now, are you able to do it more quickly? So, -6. So, just drop the sign. 6 divide by 2, 3. And this is 2. Drop the sign. -2. Divide by 2. -1. Done. 3, -1. Now 3, -1 will be the center which will satisfy this line. So 3 plus 3 times -1 is equals to a. So a is coming out as 0 in this particular case. So the line also passing through origin because the constant is coming out as 0. Right? Okay. All right. Another question. Find the equation of the circle which is concentric with the circle having twice its radius. Okay. Concentric. Do you know the term concentric? Do you know it? Let me tell you. Alright. Yeah. Concentric means that both the circle will have same center. So this circle is having center 2, minus 3. Getting it? Yes. And twice its radius. So this circle has radius r equals to square root of 2 ka square 4, 3 ka square 9. Minus of minus 3, so plus 3. 9, 10, 11, 12, 13. 13 plus 3 is 16. So root 16, r is equals to 4. Okay. So find the equation of the circle which is concentric with this circle having twice its radius. So now the radius of the original circle is 4. So radius of my circle will be double of the 4. So that is 8. And center to will be same because these things are concentric. They share the same center. And equation of the circle, now you have the center, now you have the radius. What are you waiting for? X minus 2 whole square plus y plus 3 whole square is equals to 8 square. That's it. And you're done. Okay. All right. Clear. Now you just can go ahead and expand it. Minus 4x plus y square plus 9 plus 6y equals to 64. Just solve it. You will get the final equation. Another question on your screen. The equation of the circle concentric with the circle this. Having perimeter 6 pi. Now this I will give you as a homework question, right? Because it's the same concept, just the another question from the same concept, similar concept. So you can short solve it. Okay. All right. Now we are heading towards another segment wherein we will talk about the diametric form of the equation of a circle. What is diametric form? Understand. Suppose a circle is given to you and two end point of the diameters are given. x1, y1 is first diameter and x2, y2 will be the second diameter, and yes, this if I talk about, this is your diameter. So A and B are two extremities of same diameter. If that is given, then you can easily write the equation of that circle, very easy. So x minus x1 and x minus x2 plus y minus y1, y minus y2. This is how you write the equation of the circle. Okay. Also, there is another way that, ma'am, okay, if you have A, if you have B, if you have extremities of diameter, then you can, ma'am, easily calculate the center. Center will be what? x1 plus x2 by 2, midpoint formula. y1 plus y2 by 2, correct? And this will be the radius r. So you can easily calculate AO, or you can easily calculate AB, which is diameter. Take half of it, you will get radius. This is also one of the way, but this is the lengthier way. We have very simple way. X minus x1, x minus x2 plus y minus y1, y minus y2 equals to 0. We will solve one question. Then let's see that are we able to get it or not. These 2 points are end points of diameter, right? So this is x1, y1. This is x2, y2, right? So now, as per the formula, x minus x1, that is 4, x minus x2, so x minus minus 12, so x plus 12, plus y minus 3 and y plus 1 equals to 0. This is your equation. Solve it, get it, go home. X square minus 4x plus 12x minus 48 plus y square minus 3y plus y minus 3 equals to 0. If you solve these two together, x square plus 8x plus y square minus 2y. Now, minus 48 and minus 3 will be minus 51 equals to 0. So x square plus y square plus 8x minus 2y plus 8x minus 2y. Option B clearly is the right answer. Okay. One observation, I just want you to notice this. This is a simple observation. The observation says that if I just give you that write a quadratic equation, how will you write it? So ma'am, very easy. X minus 4, x plus 12. And quadratic equation in y you have to write this time, whose roots are 3 and minus 1. How will you write it, ma'am? Y minus 3 and y plus 1 equals to 0. Yes. So can you notice, did you notice that this is the exact thing we have done? 4 and minus 12 are the roots of this. Minus 1 are the roots of this. So this is actually summation of two quadratic equations. First one with y, second one with x. First one with x, second one with y. Okay. So with this concept, with this observation, here comes our another question, which says that abscissa of 2 points A and B are the roots of this equation. Okay. Okay. So what they are saying is, this is your diameter. Point A is x1, y1. Point B is x2, y2. Right? Abscissa of points A and B is x1, x2. So if you try to write the equation, x minus x1 and x minus x2 will be the quadratic equation by abscissa of A and B. And that is representing x square. So this is actually x square plus 2ax minus b square. Correct? Same, y minus y1 and y minus y2. Now ordinate. Ordinate means y coordinate are the roots of this equation. But this is given in x. So we have to convert this in y. Y square plus 2py minus q square. So this is equals to 0. Y square minus 2py minus q square. So you just have to add these two equations. Once you add these two equations now, you will get your equation of circle. That's it. Diametric form. So x square plus y square is there. Minus 2ax minus 2py will be there. Minus 2ax minus 2py and then 2pi. Then 2py minus b square minus q square. So clearly option B is matching with this, right? Option B is matching. So option B is absolutely right. Okay, all right, clear. Now here we go with the parametric form of the equation of a circle. Now let's talk about parametric form of equation of a circle. So let me just write a general equation of a circle. Center is h, k and a general point on circle is x, y, right? Okay. So equation, you know, x minus h whole square, y minus k whole square equals to r square. But what about the parametric form? So now you will see the magic of sine square theta plus cos square theta equals to 1. Here in the parametric form, x and y will become h plus r cos theta and k plus r sine theta. That's it, right? So parametric form is x is equals to h plus r cos theta, y is equals to k plus r sine theta. Okay. So the moment you put parametric form into the original equation or standard equation of the circle, you will find that eventually it is becoming x square cos square theta plus sine square theta equals to 1. Let's just do that. X will be replaced by h plus r cos theta minus h as it is. Y is replaced by k plus r sine theta minus k as it is and is equals to r. H cancel, k cancel, r square cos square theta plus r square sine square theta equals to r square. R square cancel, again sine square theta plus cos square theta is 1. Okay. So this is how it is. Now the special case is when your center is at origin and radius is r. Basically your circle is x square plus y square is equals to r square. So in this particular case, your parametric coordinates will be x equals to 0 plus r cos theta and y will be r sine theta. That's it. So do remember this particular special case. Okay. So you can take any point on the circle as r cos theta, comma r sine theta. And in here you can take any point on the circle as h plus r cos theta plus k, comma k plus r sine theta. Now you must be wondering, but okay, got it. But ma'am, where exactly we are going to use it? So it can be utilized in multiple occasions, wherein the standard equation of a circle, existing concepts which we have studied till now, will make the question more difficult. The solution part will become more difficult, and the parametric form is a savior form. Understand? Parametric form, many students think that this is the toughest form. I don't get it. But parametric form is the most savior form when the problem is becoming complicated by using techniques of circles, existing concepts of circle. Parametric form, it will solve the whole question within 2 steps. Okay. So do not get scared of parametric form. Always make friends with parametric form. Okay. Find the parametric form of circle whose equation is this. Okay, simple. So center clearly is 1, 3. You know how to calculate center. And radius is what? Square root of 1 square plus 3 square minus 15. That is 10 plus 15 root 25 equals to equals to just 5. Okay. So now your parametric form is x is equals to h plus r cos theta and y will be k plus r sine theta. Okay. So this is how it is done. And one more thing you can do. You can just convert this into x minus 1 whole square plus y minus 3 whole square equals to 5. Convert it into perfect square form, 5 square. Now x minus 1 is equals to actually 5 cos theta. Y minus 3 is equals to 5 sine theta, and if you solve this, you will get this only. That is also one other way. I like this is my favorite way. Okay. All right. Now let us move on to the next problem. That so we have learned how to find parametric form of any circle. Now when to apply? P is a variable point on the circle. Okay. And we are here to find the locus of a midpoint of the line segment joining P to the origin. Suppose origin is this and OP. So we are looking for midpoint of OP. Midpoint of OP is suppose M. So to find midpoint, we need to know P. Now P is found by, P can be figured out by parametric form of a circle. This is your circle. If I just mark it like this, x minus 1 whole square plus y plus 1 whole square. Then it will become 1 plus 1, 2 and this will be 1 square. Yeah, if you open this, you will get this only. That means your parametric form will become x minus 1 equals to 1 cos theta, y plus 1 equals to 1 sin theta. Correct? So x equals to 1 plus cos theta and y equals to minus 1 plus sin theta. This is your parametric form. Now M will be 1 plus cos theta by 2, midpoint formula, minus 1 plus sin theta by 2. Okay. All right. Find the locus of, this is your locus, H and K. That's how we find locus. So now we need a relation between H and K. Basically, your H is basically 2 H's, 1 plus cos theta and 2K will be minus 1 plus sin theta. Or rather, 2H minus 1 will become cos theta and 2K plus 1 will become sin theta. Square and add, then you will get your locus. So 2H minus 1 whole square plus 2K plus whole square. This is cos square theta, this is sin square theta and this will be 1. So this is the final thing. H will be replaced by X and K will be replaced by Y. That's it. This is your locus. Okay. All right. So this is how it is used. I mean, the application part. One more application part. Let's look at a few questions. Parametric coordinate, very basic question. Again, they are asking parametric coordinate. So this, if you make it perfect square, this will be x minus 1 whole square minus 1 plus y plus 1 whole minus 1. Minus 2 will also be there, equals to 0. X minus 1 whole square plus y plus 1 whole square equals to 2 square. So now parametric form will be x minus 1 is equals to 2 cos theta. This x minus 1 is r cos theta. Y plus 1 is 2 sin theta. So it will become, or in this question they are talking about alpha. So x is equals to 1 plus 2 cos alpha, y is equals to minus 1 plus 2 sin alpha, right? So 1 plus 2 cos alpha minus 1 plus 2 sin alpha. Option C, absolutely right. Okay, got it. Perfect. Now, yes. So we are having another question wherein, now again, this question is basically question where the circle touches coordinate axis. Okay. The equation of circle of radius 2 units lying in the third quadrant. Okay. So in third quadrant, both your x and y are negative, right? So you can do it by option elimination as well. See, here the center is minus 2 comma minus 2. Here also center is minus 2 comma minus 2. Here also center is minus 2 comma minus. Center is 0 comma 0. Option D is wrong. Okay, so but A, B, C we are not able to eliminate because every option is having negative x, center x and y. Okay, lying in third quadrant which touches both. Acha, so this circle touches. This circle touches. Okay, not bad. So we'll draw a circle which actually touches both the axis. Clear. Now radius is 2 units. Okay, so center will be minus 2 comma minus 2 obviously because this and this both are radius. Radius is 2. So when a circle touches both the axes, the center is actually plus minus r comma plus minus r. Depends. It lies in which quadrant. Third quadrant, so minus r comma minus r. Minus 2 comma minus 2. Okay. So now just write it x plus 2 whole square plus y plus 2 whole square equals to 2 square. So this is x square plus 4x plus 4. Y square plus 4x plus 4. 4. Got it. X square plus y square plus 4x. I guess option C is absolutely right. Okay. All right. Now we will talk about intercept made by a circle. This topic is very important topic. So in here we will talk about basically two things. So intercept made by circle on axis. First, we will talk about intercept made by circle on x-axis. Okay. So, if x-axis is there, then, okay, circle. We can draw a circle, right? Yeah, this is how it looks like. And let me tell you the direct formula. X-intercept is this length. This is your x-axis. So, this length, x-intercept AB, will be 2 root g square minus c. Okay. And the intercept on the y-axis will look like this. This is your y-axis, right? And this is your circle. So, CD. So, CD length will be 2 root f square minus c. Now, understand that it is not necessary that every time a circle is intersecting or intercepting x and y axis. It can be like this, that it is neither intersecting x axis and y axis. It can be like that it is intercepting x but not intercepting y. It can be like this, that it is intercepting only y. It can be like this, that it is intercepting both. Okay. So, in that case, what will happen with this formula? If your g square minus c is positive, that simply means that your case number 1, that your case is like this, that it is making some intercept on x-axis. Okay. If your g square minus c becomes 0, that means 0 intercept. 0 intercept means this. Just touching x-axis. And third case, g square minus c negative. That means imaginary intercept. This will have square root of negative quantity is not defined. So it is neither intersecting nor touching the x-axis. Same, you can make 3 cases for y-axis as well. F square minus c greater than 0. That means this is the case. F square minus c equals to 0. Circle is touching y-axis. F square minus c less than 0. Circle is neither touching nor intersecting y-axis. So this is actually very important point. If you want to plot a circle, right, properly, so you will know the center, you will know the radius, but sometimes you might get confused. Okay, I know the center, I know the radius, but I don't know whether the circle is intersecting x-axis or y-axis, or it is like not touching at all. Okay, so in that case, you can just check from this. Okay, so let's solve some problems now, then you will understand. Find the length of intercept made by, okay, yeah, so this is the first thing. Okay, now one more concept. If a circle is, so the topic, let me write intercept on a line. Intercepts on a line. Okay, so suppose a line is given to you. Now a line is given to you, right? So line is this L, or rather let me draw a line like this, right, so that you understand nicely. Yeah, this is your line. Okay, line. This is your center, this is your radius, this is your perpendicular on the chord, right? Okay, so radius is done. Now this, the intercept is L. Suppose intercept is L. So this will be L by 2, because perpendicular from the center to the chord bisect the chord. Do you remember? So just make use of it, right? Make use of it. This is L by 2, this is R, and this you can find it out as D. D is distance between center and the line. Okay, so you know the relation R square is equals to D square plus L by 2 whole square. Make use of this relation and you are done. There will be so many problems which will be solved just by this diagram if you are able to plot this diagram. Okay, let's do one question. Okay, yes. So now this question A part says find the length of intercept made by this circle on this line. Again, I'm gonna draw same thing. Okay, Hannah, do not worry about this. This is a template based question. So A part, you have this circle, right? Then you have this line. Diagram you have to draw. Then this is center. Can you calculate center for me? So center will be 1, minus 2. Okay, 1, minus 2. This line is 4x minus 3y minus 8 equals to 0. And radius. Can you calculate radius for me as well? You're looking for this length. Okay, and double of this length will give you intercept. Okay, radius in this case will be R equals to square root of 1 square plus 2 square minus of minus 20. So this is root 25, 5. 5 is the radius. Okay. Can you, one more thing, intercept we don't know, but can we know distance between a point and a line? Line is already given, right? You know that. Okay, so D over here will be mod of, so you have to put this point in the line. How do you calculate distance between point and a line? Straight lines. Do not forget. Put this point in this line. So ma'am, 4 ones are 4, 3 2s are 6 and minus 8 upon square root of a square plus b square. So square root of 4 square plus 3 square. So 6 plus 4, 10. So 2 by 5. Okay, so this distance is 2 by 5. Now you can apply Pythagoras theorem and calculate the intercept. So intercept will be, directly I am calculating, double of this quantity. This quantity is square root of 5 square minus 2 by 5 square, right? So 2 square root of 5 square minus 2 by 5 square. So finally 2 25 minus 4 by 25, 625, so 621 by 25 ka root into 2 is equals to your intercept. Okay. All right. Yes, this is your intercept. Now, let us talk about the next question. Find the equation of a circle which touches y-axis at 0, 4. Okay. So, again, draw the diagram. This is your line, y-axis. This is your circle. Circle will look like this. Okay. Perfect. So 0, 4 is this point. This is y-axis. Now, as per the question, and cuts off an intercept of 6 units on the x-axis. So this is your x-axis. This is your x-axis. Okay. X-axis will look like this. 6 intercept. What does that mean? Suppose this is your center. Right? This is your center. So, if I draw perpendicular, it will look like this. This is your radius. And if the x-intercept is 6, so this is your 3 and this is also your 3. Okay. Find the equation of the circle which touches the y-axis at 0, 4. Okay. So, if this is 0, 4, just understand one thing. This length, okay, touching. This length and this length both will be equal. So, this will be 4 again. 4, 3, 4, 5 are Pythagorean triplet. So, this will become 5. Okay. So, now you have got radius as 5, correct? So, this radius is 5 and yes, radius is 5. This y coordinate of this point will be 4. X coordinate is something which we need to figure out. Okay. So, x coordinate will be 5. Okay. So, the radius now you have calculated as 5, correct? Radius is 5. Let me just write it over here. Radius is 5. Now, understand one thing, that these two are on same level, this point and this point. And also the distance between these 2 points will become radius only, which is 5 that you have just calculated. So, this is also 5. So, that means this horizontal distance is 5. So, that's why 5, 4. But one more thing. They have not mentioned that it is touching y-axis. So, there will be 2 cases, this and this. So, the circle, the center can lie either in first quadrant or in second quadrant. So, center will be plus minus 5, 4 and radius is fixed, that is 5. Now, you can calculate x plus minus 5 ka whole square. Y minus 4 ka whole square is equals to 5 square. This will be your answer. Okay. Alright. So, this is your final equation. 2 options you are getting for this particular equation. And now, we are heading towards this. The length of the intercept made by this circle on the line, this again same thing. Okay, you have to first of all draw the circle. Then you have to draw the lines. Y-axis. Then it is having x-axis. The length of intercept made by the circle on the line x plus y equals to 1. Okay. Notice one thing. You will not have to properly apply the formula if you just have a slightly good observation skills. Can you see the circle pass 1, 0 and 0, 1? And the line also is like this, x and y intercept. So, this line is this only. So, you just need, so this is your line. This is your line, right? X plus y is equals to 1 is this line. So, now you don't have to worry about intercept. You just need this distance. Distance between 0, 1 and 1, 0 will be square root of 1 square plus 1 square. So, root 2 is your intercept. Option B is absolutely right. Okay. Alright. So, this question also done nicely. And now, yes. Okay. And now we will talk about some more questions. Okay. The circle is touching x-axis, touching both the axes, passing through origin, touches y-axis only. So yes, here we just need to understand that x-intercept formula we have to apply. 2 root g square minus c. Okay. This is y-intercept. 2 root square root f square minus c. Correct? F square minus c. Now, so calculate g square minus c and understand. So g square minus c in this case will be 2 square minus 4. So it is coming out as 0. If g square minus c is 0, what does that mean? That simply means that it is touching x-axis. F square minus c, similarly again same values will come. 2 square minus 4, again 0, touching y-axis as well. So touching both the axis, option B in this particular case. Okay. Now, again another topic I will take. So there are some G's in case of circles. Let me tell you. S1 and T. What is the significance? S1 significance is, we will talk about it later, that what is the significance of S1. But this S1 and T both associated with a point. Okay, point x1 comma y1. Okay, suppose you have a circle x square plus y square plus 2gx plus 2fy plus c equals to 0. So S1 is nothing but just put that point in that circle and tell me the value. That's it. Point x1 comma y1. S1 is the value which you get after putting that point in the circle. So x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals to plus c. That's it. Equals to 0. We don't know. It will depend. If it is lying on the circle, the point will satisfy. So S1 value will become 0. If the point doesn't lie on the circle, it can be either positive or negative. So the importance, the significance we will understand. But right, S1 is this. Now what is T? To get the T, now this is very important. To get the T again, a point will come into the picture. X square will be replaced by x1. That you have to understand. Y square will be replaced by y1. And x will be 2x basically will be replaced by x plus x1. 2y will be replaced by y plus y1. Right? And xy will be replaced by xy1 plus yx1. So basically 2xy. Yeah. So 2xy will be replaced by xy1 plus yx1. But in this case, xy term is not there. So you can just ignore this. That's it. That's it. So if I ask you that calculate T for this circle, so you will say, okay, T value will be, ma'am, x1 plus y1 plus 2gx. So plus g and 2x will get replaced by x plus x1 plus again fy plus y1 plus c. That's it. Okay, are we ready for one question? Tell me if you are ready for a question. Yes. So this is the question which says S1 and T for the following. S1 is very simple. You have to plug in that point and that's it. So 1 square plus 2 square minus 2 into 1 plus 4 into 2 plus 1. 1 plus 4 minus 2 plus 8 plus 1. 4 minus 2 is 2. 2 plus 8 is 10. 10 plus, so this is 12. S1 is equals to 12. What about T? X square is x, x1. x1 is 1. Y square is y, y1. Okay. Minus 2. Okay. So 2x will be replaced by x plus x1. 2y will be, now 4y is 2 into 2y. 2y will be replaced by y plus 2 plus c. So T will be x plus 2y minus x minus 1 plus 2y plus 4 plus 1. 1, 1 cancel. 2y. Okay. X also cancel. 4y plus 4 is the value of T. Okay. So that's the terminologies. So S1 and T values you can easily calculate. Okay. Now this is the homework question for you. Okay. So again 2x square plus xy plus y. So S1 ke liye you just have to plug in that point. For T, Now xy term is here, so you have to apply that xy1 plus yx1. Okay, so solution is already given to you, and you can just do it and check from the PDF or from the video itself. Okay. Okay, so position of a point with respect to a circle. So if a circle is there, now there will be three cases. Okay. Point lies inside the circle. Point lies outside of the circle. Now case 1, when point lies on the circle, okay, lies on the circle, then what will happen? Suppose your circle is x square plus y square plus 2gx plus 2fy plus constant equals to 0, right? This is your circle. And now if the point lies on the circle, this x1 comma y1 will satisfy the circle, right? This is very obvious thing. This we already know. Now, do you remember that I told you there is a terminology in the circle which is S1. S1 is nothing but that value which you get when you put that point inside the circle. You satisfy that, not satisfy, but you value of x1 and y1 in the circle. You get S1. So basically your S1 value will become 0. The moment you will put the point, what will you get? You will get a 0. This is case number 1. Now case number 2 says that point lies outside the circle. Okay. When point lies outside the circle, then if you plug in that point, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals to not equals to 0, right? Obviously, it will not satisfy this time. If it will not satisfy, it will never be 0. And if it is not 0, there are only two possibilities, that either it is positive or it is negative. So if a point lies outside the circle, this value, you are going to get a positive value. S1 will be greater than 0. And last but not the least, now you have understood, I guess, if the point lies inside the circle, point lies inside the circle, then the value inside the circle, then value you're going to get of S1 will be less than 0. Okay. Let's do it with the help of the example. Let's apply this logic so that you get a better understanding. So here, consider a circle. So this is your circle and a point is there. Now we need to check whether this point lies outside the circle or inside the circle or on the circle, right? There will be three cases. So 1, 2, if I satisfy S1 value, in this case will be 1 square is 1 plus 2 square is 4 plus 2 into 1. So plus 2 minus 8 minus 4. Now let's solve it out. 4 cancel, 1 and 2 minus 8 is minus 6. So this is minus 5. Minus 5 is a negative number. Negative sign indicates that it is lying inside the circle. So option A is absolutely right. As simple as that. Very basic question, right? Okay. Now let us move on and talk about not this, but yes, actually these types are very, very important. Let me tell you. Yeah. So this is all about position of point with respect to a circle. Now, understand this is a very, very important topic which I'm going to tell you right now. For JEE main, especially you can get a direct question like this in your JEE main. These type of questions were also asked in JEE main 2024, 2023 and 2022. Just go and check it out. And these type of questions, they also ask from the chapter complex number. The same type we have done in complex number. Go ahead and check out my video on complex number. Same type we have done. Okay. So now again, the type is there is a circle and there is a point. Okay. Point is suppose P, which is x1, y1, that is given. Okay. Now we are looking for distance of this point. So basically, we are looking for maximum distance of P from the circle That is one thing. First, minimum distance of P from the circle, right? Okay. So, how to tackle this? First of all, maximum or minimum distance, the logic is that always lie along the common normal of the circle. Now, normal, the word normal, maybe you don't understand the word normal, especially if you are in class 11th. So you understand one thing, basically the smallest distance. So smallest distance will be this, right? So smallest distance over here will be AP. Okay, so minimum distance is AP and maximum distance will be BP. How to get BP? How to get AP? And what is the basically the geometrical position of A and B? Okay, so what I'm gonna do is this A and B is nothing but forming a diameter of this circle. That is first thing. Okay, all right. So that's why minimum distance is PA, maximum is PB. Okay, let me write it this way: PA and PB. PB and PA. Correct. Now PB. So PB will be, this is your center, right? O is your center. PB will be PO. PO or OP, you can say OP plus radius of the circle, right? So OB plus OP is your AP, that is maximum distance. So always you can easily calculate distance between point P and the center, right? You cannot calculate distance between point P and point A because you don't know point A, but you know the center. So always think about this. OP plus radius will give you maximum distance. What is O? Distance between center and that point. And PA will be what? OP minus R, right? Again, OP is distance between O and P, center and P, minus, if you subtract this, then you will get the AP, right? Let us just apply this logic, okay? And in a question, let's do that. Find the greatest and least distance of point P 2, 1 from this particular circle, okay? All right, so we will take a circle over here, okay? Now center of this circle can we calculate? So center will be 3, minus 2. This is your O, okay? And radius of this circle will be, tell me, radius will be square root of 3 square 9 plus minus 2 square 4 minus 12, so plus 12. So 12 plus 4 is 16 plus 9 root 25 and root 25 is plus 5, okay? So radius is 5. Now understand that P is the point 2, 1. We don't know what is the position of point P, okay? So there are two ways to go about it. First one is put 2, 1 in this circle. So calculate S1 and then understand that whether 2, 1 lies inside or on the circle or outside the circle, okay? So S1, if you put 2, 1, 4 plus 1 minus 6 to the 12 plus 4 minus 12, and clearly this is coming out as negative. That means point P lies inside the circle, okay? And also, if you pick this point P 2, 1 and calculate OP distance, right? OP distance. So OP distance is 3 minus 2 square and minus 2 minus 1 square. So clearly you are going to get 1 plus 9 ka root, that is root 10, okay? Now OP is root 10. And what about radius of this circle? 5, right? OP is root 10 and radius is 5. Radius is this, which is 5. Now you tell me, 5 is greater or root 10 is greater? Obviously, root 10 is 3 point something. Okay, so if 3 point something, that means distance from O to P is less than 5, right? P will lie somewhere over here, then only this OP will become 3. Are you getting my point? Okay, so P is lying inside the circle. That's what my whole point is. So if P lies inside the circle, then the greatest and least distance I have already told you. So maximum distance will be OP plus R, obviously in modulus, and minimum distance minus R in the modulus. Okay, so OP plus R. OP is what? OP is root 10 plus 5 and root 10 minus 5 modulus. Okay, so root 10 minus 5 obviously will be negative. So that's why 5 minus root 10 will be the minimum distance. Okay, this is your maximum distance. Perfect. Okay, clear. Now, let us move on to the next problem. The greatest distance of the point P from the circle. Okay. Acha, okay. So there will be actually 3 cases. Now, the point in this situation, point can either lie on the circle. If point is lying on the circle, tell me the greatest and least distance. The greatest and least distance will be 0, right? Because point is lying on the circle. And now, if the point is lying inside the circle or outside the circle, just take care of this modulus. Okay. So now, in this next question, greatest distance of point 10, 7 from the circle. Okay. So greatest is OP plus R, where O is center, P is this point. So let's calculate OP now. Okay. So OP, so for that center of the circle, let's calculate. 2, 1 will be the center, correct? P is your 10, 7. OP, can you tell me? 10 minus 2 ka square is 8 ka square and 6 ka square. So it is coming out as 10. What is the radius of this circle? Tell me. G square plus F square. So 2 square plus 1 square minus 20. So 20. So this is 5. Obviously, OP is coming out as greater than R. So distance between center and point P is greater than radius of this circle. Are you getting my point? So outside. This is lying outside the circle. Another method is just satisfy that point. If it is positive, you will see that it is outside. Now again, OP plus R is the maximum distance. The final value will be OP is 10 plus 5, that is 15. Option B. Okay. You can just go ahead, draw the same diagram and understand what is happening. So 15 is the correct answer. Okay. So now we have talked enough about position of a point with respect to a line. Position of a point with respect to a circle we have talked about. Now, the second topic is all about position of a line with respect to a circle. Okay. Now you have to listen to me carefully. Circle number 1, circle number 2, and oops, small circles will work better. Yeah. Circle number 1, circle number 2, circle number 3. And now let's take a line. Okay, so there will be 3 cases. Line could be a secant or could act as a chord to a circle. Line can be a tangent to a circle. And line can neither be tangent nor be secant to a circle. Case 1, 2, 3. First, second, third. Okay. First case is when your line is secant. Okay. Secant. Second is tangent. Third is neither secant nor tangent. Okay, neither secant nor tangent. So first thing, tangency. Let's think about tangency, and this condition is very important, by the way. So if this is a center, okay, and if I drop perpendicular to this line, okay, just as simple as that. If I drop a perpendicular to this line, it will look like this. Okay, right? Now, perpendicular or from this point center, perpendicular from the center on this line, this length, let us mark it as P. Okay, as per the diagram, this distance between this center and the line is actually equal to the radius of the circle. So in this case, P is equals to R. P is what? P is distance between center and line. And R is what? Radius. So this is the condition. P is equals to R. Okay. All right. Clear? Perfect. Now, in case of secant, this is your, again, center, and P is this. P is this line. Perpendicular distance from the center to the line is P. Correct? Perpendicular, now distance between center and this, basically radius. I am talking about the radius. Tell me, this radius length will be greater than perpendicular distance, right? So when radius is greater than P or P is less than R, you will get a secant, and in this case, clearly, this is your radius and this length is P. So P greater than R will be neither secant nor tangent. Okay, so these are the three cases wherein condition of tangent is very, very, very important. Okay, all right. So yes, you can see the diagrams over here. In this case, your perpendicular distance is less than R because line cuts the circle, line is tangential to the circle, D is equals to R. And when D is greater than R, then line does not meet the circle at all. Okay. Chalo. So can we just do a little exercise? Can we just check the position of given line with the given circle? Can we do that? Let's try it once, okay? Find out the position of, yes. So in this case, we have to first of all figure out the center of the circle and radius of the circle. Center of this circle, let us mark it as O. O will be equals to 1 comma minus 2. Radius will be equals to square root of 1 plus 4 minus 4. So radius is 1. Okay. Now radius you've got. Now perpendicular distance P. So there is a circle. There is 1 comma 2 minus 2 and we don't know the position of line. So what we are doing is we are calculating the distance between this point O, which is center, and line L. Okay. Alright. So P over here will be, you know, the perpendicular distance. How do you calculate? This is your line 2x plus y plus 1 equals to 0. So you put that point in the line. So P will be modulus of 2 ones are 2 minus 2 plus 1 by root of 2 square plus 1 square 5. That's it. So P is 1 by root 5. Okay. Which is, by the way, less than 1. Right? 1 by root 5 is a fractional quantity. Correct or not? So 1 by root 5 and R. So in this case, 1 by root 5 will obviously be less than 1. So P will be less than R. So perpendicular distance will be less than R. So that means perpendicular distance being less than R means line cuts the circle at 2 points. It is a secant to the circle basically. Okay. So position is cutting the circle. All right. Clear? Okay. So I guess now you can check it out on your own whether it is tangent or it is secant or neither tangent nor secant. Now there is another method also, one more method to check whether the line is tangent or secant or neither tangent nor secant. Okay, very simple. Suppose you're having a circle, suppose you're having a line. Circle is having again x square plus y square plus 2gx plus 2fy plus c equals to 0. Line is ax plus by plus c is equals to 0. Okay. So now you have to solve this line with the circle. How to solve two curves? You can just calculate the value of y from here. Plug in this. Okay. So once you plug in the value of y from the line into the circle, you will get a beautiful quadratic equation in x. Yes. So solve line with circle to get a quadratic equation. Okay. And that quadratic equation is what? Quadratic in x, or it can be quadratic in y depending upon how you have solved it. So quadratic equation, now you have to check for the discriminant of the quadratic equation. Because over here in the very first case, if you observe, so you've got quadratic in x, suppose, and you have that quadratic has discriminant greater than 0. That means you will get two values of x. Solving line and circle is giving you two values of x. What does that mean? That line and circle intersect each other at 2 points. This is the first case. Now, if you're getting a single solution, that means discriminant is equals to 0, line is tangent to the circle. And the condition for neither secant nor tangent is discriminant less than 0, line does not meet circle. Okay, all right, yes. Let's do one thing now. Let's just do one question. We'll find out the position of given line with respect to a circle, right? So again, same thing. What we will do in this case is x square plus y square equals to 1 and line. So now this line is y is equals to root 2 minus x. This line, if you satisfy in this circle, you will get x square plus root 2 minus x whole square equals to 1, right? So x square plus 2 plus x square minus 2 root 2x equals to 1. 2x square minus 2 root 2x plus 2 minus plus 1 equals to 0. So this is your quadratic in x. Now discriminant of this quadratic will tell you whether it cuts or touches or do nothing with the circle. So discriminant will be b square. So 2 root 2 whole square minus 4ac. So 8 minus a, oops, discriminant 0, that means line becomes tangent to a circle. So this is actually method number 2. One more thing what you can do is, again, you just find out the center of the circle, which is 0, 0, radius of the circle 1, and perpendicular distance from this center to this line. So P will be equals to 0, 0. You satisfy root 2 by, okay, P is also coming out as 1, radius is also coming out as 1. So when R is equals to P, that means your line is tangent to the circle. Okay, all right, clear? Chalo, one more question. Are we ready for it? Now, if C is this is a given circle and L is given line, and now, yes, again the same thing we have to do. We have to check whether this line intersects the circle, touches the circle. So let it keep as a homework question. Do let me know your answer in the comment section, okay? So again, you can apply method 1, you can apply method 2. In method number 1, find out the circle center, find out the radius, okay? Then if you have a center is, by the way, 2, minus 5. So 2, minus 5 say distance between point and the line calculate. Now compare. The perpendicular distance is equal to radius? Yes, ma'am. So tangent. No, perpendicular distance is lesser than radius. Secant. Perpendicular distance is greater than radius. Neither secant nor tangent. Okay. All right. One more homework question. Okay. This is also homework question. Again, same thing in this case. So center is also given. Radius is also given. Center is 2, 3. Radius is your root 11. Don't forget, it's not 11, root 11. Okay. And now 2, 3 and x plus y plus 1 distance and calculate. Again, another homework question. Now we are having another topic, which is equations of a tangents to a circle. Okay. All right. So, yes. So what we will do is, we will take a line y is equals to mx plus c. This is your line. And now we have a circle which is x square plus y square equals to r square or a square. Okay. So in this case, center is origin, radius is a, and this line is tangent. Okay. So you know the condition of tangency, right? Condition of tangency is perpendicular distance p is radius. In this case, radius is a. In this case, p is what? So p is, you just have to calculate distance between 0, 0 and this. So 0, 0 satisfy in this. So you will get minus c, but you have to take mod. So mod of c by square root of coefficient of x square plus y square. So this is what you're going to get. So over here, c will be equals to, if you just remove the mod, plus minus a root 1 plus m square. Okay. So now constant is coming out like this. So now equation of tangent comes out to be y equals to mx plus c. Now c is plus minus a root 1 plus m square. This is, you need to like remember it, okay? And obviously there will be two tangents of slope m. So if I'm saying that, okay, slope 2 is there and you have to write equation of slope 2, obviously there will be two tangents. You can see, intuitive, quite intuitive. Two parallel tangents will be there of same slope, okay? So let's do one question. Find the tangent to this curve which is parallel to this. Now tangent to x square plus y square is equals to a square is y is equals to mx plus minus a square root 1 plus m square. A is the radius, right? So do you know the slope? So slope of this line is minus 3 by 4. Correct? You know how to calculate slope of any line? Trick, minus a by b. Okay? So yes, tangent. Now y is equals to mx plus minus. Okay? So now what you need to do is radius. What is the radius? What is the value of a? So m is this and from here a is 3. Now just plug in the value and you're done. Y is equals to minus 3 by 4x plus minus 3 root 1 plus 3 by 4 square. So y plus 3x by 4 equals to plus minus 3 square root of 25 by 16, correct? So 4y plus 3x equals to plus minus 3 into 5 by 4. Okay? By 4 is also there, right? Correct. So 4y plus 3x is equals to plus minus 15 is your answer. Okay? So there will be two tangents of the same slope. Correct? So tangent which is parallel to this will have this slope and equation as this. So just plug in the values and solve it out. Okay. All right. Now let us move on to the next problem. Y equals to x plus c will intersect this circle in 2 points if, okay. So in here again we have to apply that condition that if you solve this line with this circle, you will get 2 points. So discriminant will be greater than 0. Just solve line and curve y is equals to x plus c. So x square plus y will be replaced by x plus c square equals to 1. X square plus c square plus 2cx equals to 1. 2x square plus 2cx plus c square minus 1 equals to 0. Right? So now discriminant of this will be 2c square b square minus 4ac. Right? So discriminant will be, it is going to become, now you want discriminant to become what? Greater than 0, right? In two two coincident points. Not two distinct points, coincident points. Coincident point means tangent. Okay, basically what they are saying is two equal points, right? Two equal roots. So discriminant is equals to 0. So yes, this is going to become c square minus 2c square plus 2 equals to 0. So c square is coming out as 2. C is equals to plus minus root 2. That means option C is absolutely right. Okay. All right. Okay, perfect. Now let us move on to the next problem. Equations of tangent to this circle which are perpendicular to this line. Again, similar type of question is there. So now slope of this line will be what? Ma'am, minus 2 by 3. Okay. Now slope of line which is perpendicular, slope of our tangent, right? Our tangent is perpendicular to this line, will be negative reciprocal of minus 2 by 3. So reciprocal of minus 2 by 3 is what? Minus 3 by 2, negative. So 3 by 2. So slope of our tangent is 3 by 2. Your radius A is 3 again. So now you just write down the equation y is equals to mx plus minus a square root 1 plus m square. So clearly y is equals to 3 by 2x plus minus square root of 1 plus m square. So 9 by 4. So this is going to become y minus 3 by 2x equals to plus minus square root of 13 by 2. So 2y minus 3x equals to plus minus root 13, right? So 2y minus 3x, 2y minus 3x. So 2y minus 3x, A and C are wrong. 2y minus 3x, D is also wrong. So if you multiply minus sign is this, 3x minus 2y is equals to plus minus, there is 3 also, no? 3, right? 3. Option B is absolutely right. Okay. All right. Perfect. Now, let us move on to the next problem. Next problem says find lambda such that this becomes tangent. Again, you have two options. Just compare it with y equals to mx plus minus a square root 1 plus m square, right? Because we know the tangent of this circle is this only. Now, if y is equals to 2x plus lambda is the tangent, then m should be equals to 2. That is first thing. Radius, so you know, is root 5. Just plug in the value, get your answer. So, your basically constant term, right? Constant term is lambda. Y is equals to mx plus c. Lambda in this case will be plus minus a square root 1 plus m square. That's it. Lambda will be plus minus root 5 root 1 plus m square. So that is 2 square. So lambda is equals to plus minus root 5 root 5. So lambda is plus minus 10. This is your final answer. Okay. All right. Clear? Okay. Now let us move on to the next problem. Okay. Now one thing. Before moving on to the next problem, I would like to tell you that okay, so x minus 0 ka square plus y minus 0 ka square is equals to a square has a tangent and whose equation is tangent equation. Tell me, ma'am, equation of tangent is y equals to mx plus minus a square root 1 plus m square. Now, if you have a generic circle, x minus x1 square plus y minus y1 square is equals to a square, then ma'am, what will be the equation of tangent? In this case, you just have to replace y by y minus y1 and x by x minus x1 is equals to, that's it. And the rest of the things will be same, right? So this y will be replaced by y minus y1, x will be replaced by x minus x1, where x1 and y1 are the centers of the circle, okay? So, now, the equation of this tangent, okay, will be what? Tell me. Ma'am, y minus y1 equals to m x minus x1 plus minus radius 1 plus m square, right? Okay, clear. So, now, yes. Let us just write down, let us just calculate center of the circle. Okay, center of the circle will be, tell me, 2, 4. Radius will be 4 plus 16 plus 5. Okay, so basically radius is 5. So again, y minus 4 equals to m. So m we need to get it from here. Minus 3 by minus 4. So slope will be 3 by 4. So 3 by 4, x minus x1, so x minus 2 plus minus 5 square root of 1 plus m is 3 by 4 square. Just solve it out and you will get the value of lambda right away. Okay. Y minus 4, ma'am, 3 by 4x minus, this will be 3 2s are 6 by 4, that is, okay, so this is 3 by 2, correct, 3 by 2 plus minus 5, okay, and this is the, if you solve it, it will become 25 by 16, so 5 by 2, okay, correct. Now this is y minus 3 by 4x is equals to 4 minus 3 by 2 plus minus 25 by 2, okay. So 4y minus 3x is equals to, now if you take plus sign, you will get another constant, minus sign another constant. 4 2s are 8. 8 8 minus 3 is 5 by 2. Sorry, this is, yeah, plus minus 25 by 2. Now, if you take a positive sign, then you will get 30 by 2, that is 15. So 4y minus 3x becomes 15 for positive sign. And if you take negative sign, that is minus 20 by 2 to minus 10. 4y minus 3x is equals to minus 10. Now, if you want to compare it with your equation 3x minus 4y, you just have to multiply with a negative sign. 3x minus 4y is equals to minus 15. So, your lambda becomes minus 15. 3x minus 4y is equals to plus 10. So, lambda becomes plus 10. So, you're getting two values of lambda, minus 15, plus 10. Both will work in your case. Okay. All right. So, this is how it is done. You just calculate the equation of tangent in your own terms, and then you can compare. Okay. All right. Now, okay. Now that you have seen that slope form of tangent. So, you have seen slope form of tangent. Okay. So, slope form of tangent is y minus y1 equals to m x minus x1 equals to, plus minus a 1 plus m square root. Okay. Now, there is point form of tangent. Okay. Understand. This is important. Suppose you have a circle. Bad circle. Suppose you have a circle and a point is lying on this circle x1, y1. Right? Point is lying on the circle. So now, t equals to 0 will give you equation of the circle. Now, you must be wondering, ma'am, what is t? I should ask you what is t. Tell me what is t. So, t, remember we discussed what is t, the terminologies. X square will be replaced by x, x1. Y square will be replaced by y, y1. Then x will be replaced by, basically 2x will be replaced by x plus x1. 2y will be replaced by y plus y1. Remember we did some exercise. So, if a point is lying on that circle and tangent, the point of tangency is given to you, then only you can use t is equals to 0, which we are going to use in this case. Find the equations of the tangent drawn from 1, 4. Now, 1, 4, okay, 1, 4, you need to check whether 1, 4 is lying on the circle or not. If it is lying, then only you can write, otherwise you can't write. So, 1, 4, if you try to satisfy it, it doesn't lie on the circle. So, you can't apply it. So, you have only one option left. Y is equals to mx plus c. So, y is equals to mx plus minus 4 square root 1 plus m square is the tangent. Correct? Now, 1, 4 is lying on the circle, right? So, 1, 4 is lying on the tangent. So, 1, 4 we have to satisfy in this tangent and you're done. Boom. Right? So, 4 is equals to m plus minus 4 square root 1 plus m square. Now, you just have to get the value of m. Once you get the value of m, you can get the equation of tangent, right? 4 minus m is equals to plus minus 4 square root 1 plus m square. Square it both the sides. 4 minus m whole square plus minus equals to plus minus 4 1 plus m square. Correct? 16 plus m square minus 8m equals to 16 1 plus m square. Okay, 16 plus m square minus 8m equals to 16 plus 16m square. 15m square plus 8m. 16 is gone. Okay, so 15m square. So, m is coming out as 0 or minus 8 by 15. If m is 0, then clearly, if m is 0, right, first m equals to 0. If m is 0, then y is equals to, m is 0, this is gone, plus minus 4. Right, this is your equation of tangent. If m is minus 8 by 15, right, so you can just plug in the value in this equation and you can get the answer. y is equals to minus 8 by 15 plus minus 4 square root 1 plus 8 by 15 whole square. Correct? And you will get the answer. Okay? Clear? Perfect. Okay, so the next question says, find the locus of point of intersection of pair of tangent to this circle which contains, what is happening? Okay, which contains an angle of 60 degree. Okay, so let us create a diagram for this. So there is a circle, then we are having a point, okay, from which two lines are drawn, and these two lines are nothing but tangents to this circle, and the angle between tangent is 60 degree. Correct? Okay, so if this angle is 60 degree, okay, so this angle is 60 degree, this is 0, 0, right? Find the locus of point. This is your h, k, correct? H, k. And if this is your center, if I join the center to this point h, k, why I am not able to join it? Yeah, perfect. So now this is your radius, which is 4, right? Radius is always perpendicular to the tangent, correct? If this whole angle is 60 degree, understand this angle will be 30 degree, 30 each, okay? 30, 30 each. Now h, k. So in this, I'm going to apply the sine 30 degree. Sine 30 degree, this is 0, 0. Sine 30 degree will be perpendicular 4 upon hypotenuse. In this case, what is hypotenuse? Distance between point P and the center. So 4 upon OP. Now sine 30 degree is 1 by 2, which is 4 upon OP, distance between 0, 0 and h, k, square root h square plus k square. Cross multiply, square root h square plus k square is coming out as 8. So x square plus y square is equals to 64 is your final locus, right? So what does that mean? Understand the geometrical meaning behind this. So they are asking that find the locus of point tangents are drawn and the angle between those two tangents should always remain 60 degree. So what we are saying is that this locus is again a circle with center 0, 0. So here 4 radius circle is this and 8 radius circle will be this. Basically these two are concentric circle, if you understand. Okay, these two are concentric circle, right? Yeah, these two are concentric circle, correct? So now what we are saying is, if you take any point on the outside circle, that is with center 8, with radius 8, and you draw any two tangents on the inner circle, which is this circle, right? You will get 60 degree angle only. Are you getting my point? Okay. So this is what the question was all about. Now let us move on to the next problem, a similar type of problem. We are looking for locus of the point of intersection of the perpendicular tangents to this circle. Okay, so again, if I just try to plot the graph, this is your circle, right? And locus of point of intersection of perpendicular tangents. So now this time what will happen? Your graph, your point will look, your point will look like this. And now if you draw two tangents from this point, h, k, right? h, k, p, 90 degree. This is 90 degree, right? So yeah, this angle is actually 90 degree. Okay. This angle is 90 degree. So in this case, your half angle will be 45 degree. So if I join the point P to the center like this, this will become 45 degree. Okay. And if I drop a perpendicular, it will look like this. Again, sine 45 degree. Tell me, this is your radius and OP is hypotenuse. So perpendicular by hypotenuse. So radius upon OP. 1 by root 2 is radius is A and OP is again square root h square plus k square. Now x square plus y square will be equals to 2a square, right? This is your locus, option A. Now notice one thing, that the radius of this circle is nothing but root 2a, right or wrong? Yes. So now what does that mean? That you have a circle whose radius is a, that is given to you. Now if you take on a concentric circle whose radius is root 2 times the original radius. Basically radius is root 2 times the original radius. So this is your again concentric circle with radius is root 2 times r. If you take any point on this circle and if you draw a pair of tangents, angle between those two tangents will be 90 degree. And here comes the concept of director circle, my dear students. Director circle is a locus of a point of intersection of perpendicular of any curve. Okay. So in case director circle basically has to be a circle. In the case of circle, see, in case of circle, any circle, if you ask me that, ma'am, just tell that what is the locus of pair of tangents, right? And basically locus of point of intersection of perpendicular tangent drawn to a circle is a circle only of root 2r radius, right? Root 2 times original radius. Okay. So yes, root 2 times original radius. So if any circle is given to you, suppose x minus h square plus y minus k square is equals to r square. Okay. Now director circle of this will be same. Center is same, x minus h square, y minus k square, but radius will become root 2 times r. So this is your original circle and this original circle will have a DC. This is it. Now on DC, if you take any point and if you draw two tangents on the original circle, those two tangents will be perpendicular to each other. That's the concept. The same concept we are going to study in parabola, ellipse and hyperbola. Okay. All right. Chalo, perfect. Now let us just combine the tangential part of everything. So what we have covered till now, slope form of tangent, you know, y is equals to mx plus c. Tangent on a circle at a point, when point lies on the circle, will be given by t is equals to 0. And there is a parametric form also. One by one, let us just revise and solve some good problems on it. First, so we have solved y is equals to mx plus c, enough problems. Now t is equals to 0 is remaining, right? Suppose minus 1 comma root 3 is that point and this is your circle. And you have to write equation of circle using t is equals to 0. So you just have to replace x square by x x1, y square by y y1, and this will be equals to 4. x1 is minus 1, y1 is root 3. Now plug in minus 1 and root 3. That's it. So minus x plus y root 3 equals to 4. Done. Done. Okay. Now again same thing, 2 comma 4 is the point. This is your equation of circle. Again x x1. So x x1 plus y y1. Now 2x will get replaced by x plus x1. So minus x plus 2. 2y will get replaced by, tell me, y plus 4. And if you solve it, you will get this. And this will be your equation of tangent at 2 comma 4. Okay. Now let's do one thing before actually going on to. Okay. Now let's talk about the parametric form. Very easy. Okay. So parametric form, do you remember parametric form of circle? Now this is parametric form of tangent. Both two are completely different things. Do you remember parametric form of circle? Yes, ma'am. So can you take a point on circle for me? If this is your circle, can you take a point for me? Ma'am, x square plus y square is equals to r square. So point will be, ma'am, r cos theta, comma r sin theta. Now, same thing, t is equals to 0. You have a point, right? So can you just write equation on that point x1, comma y1? So x1 is r cos theta, y1 is r sin theta. So x square plus y square is equals to r square. x1 plus y1 equals to r square. R cancel. So x cos theta plus y sin theta equals to r. That's how you write equation of tangent in parametric form. Okay. All right. Now, one more concept, because remember I told you that there are two terminologies, S1 and T. So T we have figured out where to use, but S1, what is S1? So suppose an external point is given to you and a circle is given to you, right? External point and circle. If external point is given, then obviously you can draw a tangent from that external point, right? So tangent is drawn, and actually from external point, two tangents can be drawn, right? Now two tangents, PT and let's say PT1. Both tangents length will be equal, right? This PT is nothing but length of tangent portion. Otherwise, this line is infinite, but P is that external point, T is point of tangency. Now PT, can you see PT and PT1, both will have equal length. That we have already studied this theorem in class 10th. And the length is given by square root of S1. By the way, do you remember S1? S1 is nothing but you just put that point into that circle and you will get it, right? So if you take square root of that quantity, you will get length of tangent. Okay. So suppose point is lying on the circle, then obviously clearly the length of tangent is 0 and square root of S1 will also be 0. And if a point lies inside the circle, remember S1 becomes negative. Square root of negative does not exist. Length of tangent is not defined because from internal point you cannot draw any tangent. So if only a point is lying on outside the circle, then root S1 is the length of tangent. Okay. And this S1 is also called power of a point. Okay. With respect to circle. All right. Let's do one thing. Let's solve some problems and understand. Find the length of tangent from point 6, 8 to this circle. Very simple. So length of tangent is nothing but square root of S1. Square root of S1 is you just put that point. Okay. So square root of, now put that point. 6 square plus 8 square minus 4 into 6 minus 8 into 8 minus 5. 36 plus 64. 100 minus 24 minus 60. Oops, sorry. Here only 64 and 64 are gone. 36 minus 24 minus 5. So 36 minus 29 is 7. Root 7. So root 7 in this case will be length of the tangent. Okay, clear? Shall we move on to the next problem? Yes. Okay. Now point P minus 1, 2 is a point on this circle. Okay. Then the equation of tangent through P will be A, B, C, D. Okay. First of all, minus 1, 2 is lying on the circle. So tangent can be written by T is equals to 0. Remember, only when the point is lying on the circle, then only you can use T is equals to 0. Otherwise, you cannot use. Okay. Simply, so x1, x into x1. x1 is minus 1 plus y square will get replaced by y1. So y1 is 2 minus 4x. Now 4x can be written down as 2 into 2x. Multiply now 2x is x plus x1 plus 4y. 4y is 2 into 2y. So 2y plus 2 minus 17 equals to 0. Minus x plus 2y minus 2x plus 2 plus 2y plus 4 minus 17 equals to 0. So this is going to be minus 3x, then plus 4y, okay, Then we are having 2 plus 4, 8. 6 minus 17. Okay. 6 minus 17 is minus 11 equals to 0. So 3x minus 4y plus 11. That is option B is matching with the 3x minus 4y plus 11 equals to 0. B is absolutely correct. Okay. So in this manner, you can use t is equals to 0 to write the equation of tangent. Okay. All right. Yes. Now, sometimes you have to draw the tangent from external. Now you have seen there are two scenarios. So you can draw tangent on the point from the circle only. Basically, you can draw a tangent when the point is lying on the circle. That's what I'm trying to say. So in that case, only one tangent can be drawn. But if the point is lying outside the circle, pair of tangents can be formed. Right? Pair of tangents can be formed. Okay. So this scenario is pair of tangent. Okay. Are you getting my point? Okay. Now, if a pair of tangent is drawn from a point P to a circle, then angle between pair of tangent is given by this. 2 radius of the circle, L is length of the tangent upon L square minus R square. Understand? This is your circle. This is your point P. O is the center, right? And now PA and PB are the length of tangent. Here A and B are what? Tangency, point of tangency, right? So PA is length of tangent, PA, and PB is also length of tangent. Both are equal. Okay. And OA and OB clearly are the radius. Clear? Okay. Now if theta is the angle between PA and PB. So this whole is theta. That means this angle will be theta by 2. This angle will also be theta by 2. Right? So can I calculate tan theta by 2 from here? Tan theta by 2. Tell me. Perpendicular theta by 2 is this. For this is 90 degree because obviously radius and tangent are always perpendicular to each other. Okay. So R upon L is perpendicular by hypotenuse. Okay. Tan theta by 2. Now you know that tan theta is nothing but 2 tan theta by 2 upon 1 minus tan square theta by 2. Right? So can I just plug in the values? 2R by L upon 1 minus R square by L square. If you solve it, take LCM. 2RL upon L square minus R square will be your tan theta. This is what is given over here. So whenever you have got that figure wherein angle between pair of lines is asked from you, use this formula and you are done. Okay. All right. Now, length of AB. So basically, length of chord, right? Can you see? So now in this case, if external tangent is drawn, two tangents from external point is drawn, obviously from the point of tangency, basically, this will be your chord. Now, length of chord, if you want to find, how will you find? So here, we are looking for length AB. Okay. All right. This is again theta by 2. Okay. So can you calculate sine theta by 2 from here? Sine theta by 2 is, ma'am, perpendicular upon hypotenuse, first of all. Sine theta by 2. In this big triangle, this is 90 degree. So this is theta by 2. Perpendicular is R. Hypotenuse is OP. So R upon OP. Okay. OP is what? Hypotenuse. So R and L. So by Pythagoras theorem, OP is R square plus L square. This is sine theta by 2. Now understand. If this is theta by 2, this is 90 degree. This will be 90 minus theta by 2, correct or not? Right? Now, same thing. Look at in this triangle, this small triangle. Right? This is also 90. This is 90 minus theta by 2. This is 90. What about this? What about this? Again, theta by 2. Right? This angle is theta by 2 again. Again, sine theta by 2 if I find. Sine theta by 2 is okay. not sine theta by 2, but cos theta by 2. Yes, let's take cos theta by 2. So cos theta by 2 in this case will be base upon hypotenuse. So this will be L upon. Okay. Same, cos theta by 2 in this small triangle. This is theta by 2. So this is theta by 2. So AB ka half upon R. So AB ka half and R. Equate. Now equate them. So AB upon 2R is equals to L upon R square plus L square ka root. So AB, length of AB, now cross multiply. This will be 2RL upon R square plus L square ka root. Okay. So these two formulas are basically we have just obtained by what? By applying geometry, basic geometry, right? So very like good question can be formed from this particular, these two formulas. Okay. All right. Now, let's talk about common tangents of the circle. Okay. So in various situations. So can you see there are multiple situations we have created. First case, when both the circles are not touching each other, not intersecting each other. Okay. So in this case, how many common tangents can be formed? So in this case, 4 common tangents can be formed, right? 1, 2, 3 and 4. Okay, 4 tangents. Case number 1. Case number 2, now can you see that gradually the circles are coming together? First of all, 2 circles are poles apart, not touching, not intersecting. Now the circles have come closer. Now the circles are touching at single point. How many tangents? Common tangents. 1 common tangent, 2 common tangent, 3 common tangent. So see, 4, then 3. Now a little more closer. So now circles are intersecting at 2 points. Only 2 common tangents. Now some more closer, wherein one circle is lying inside the circle and touching also. Right? So they have come closer in such a way that the second circle just slips inside the circle. So only 1 common tangent, and when one circle is completely inside the circle, basically they are not touching each other, so 0 common tangent. Okay. So these are the 1, 2, 3, 4, 5 cases. Okay, 5 cases, 5 good cases. Now in the very first case, the diagram and all looks very good. But what will you do when 2 circle equations are given to you? You cannot imagine, you cannot visualize directly, na, कि these 2 circles are not touching each other, or these 2 circles are touching each other, or these 2 circles are intersecting each other, or these 2 circles are contained in each other. For that, you have to apply some mathematical condition. Check that which case, which criteria, which condition out of these 5 options you are getting into. Okay. So for that, very simple. Suppose both the circles are neither touching nor cutting. They are very apart. So now the distance between their centers, C1 and C2, will be greater than R1 plus R2. There will be some gap also. So C1, C2, distance between center is hold on. Distance between center is greater than R1 plus R2. Okay, first case. I hope that this is clear. Now, this time each other externally. Okay. So in this case, C1, C2 will exactly be equal to R1 plus R2. Okay. And in third case, the center, distance between center becomes, because this R1 is this and R2 is this. Okay. So R1 plus R2 will be greater than C1, C2. But what will happen over here, you have to apply one more condition. Okay. And that condition will be C1, C2, distance between center will be R1 minus R2. Okay, right? So So this is also, now one circle is touching each other internal. This is internal touching. This is external touching. This is internal touching. So see, these two cases are little bit similar. Equality is there. Here C1, C2 is equals to R1 plus R2. Here C1, C2, distance between center, will be radius 1 minus radius 2. So this is R1 minus R2. R1 minus R2. Okay, bigger minus smaller, or you can take mod as well. And now in this case, C1, C2 will be less than mod R1 minus R2. So basically, when the last case is there, one circle is contained, C1, C2 is less than R1 minus R2. So see, I guess first case you will remember it, that distance between center is greater than sum of radius. Second case also you will remember, yes. Third case also you will remember, because second and third are very close. External touching में R1 plus R2, internal touching में R1 minus R2. So second and fourth are similar. Now third and fourth are something which might create confusion because there are two inequalities. So see, third may just remember when a circle is touching at 2 points, there are two-sided inequalities. So this inequality, so you will definitely know that C1, C2 is less than R1 plus R2 and greater, and this case will be C1, C2 is less than this. Okay, just remember it like that. Chalo, let's solve some problems, then only we can understand. Now, this is the chart basically. When two circles are separated from each other, there will be 4 tangent. Now, direct tangent is this. Direct means when the tangent is lying on the same side of circle. TCT, transverse common tangent, is when it is like, see, this is transverse. Transverse means one circle is lying below and one is above. This is also transverse. One is this side, second is this side. So direct, two transverse. Now in this case, 3 common tangent. This is transverse and 2 are direct. In this case, 2 common tangent, both are direct. In this case, 1 common tangent and 0. So gradually, the number of common tangents are getting reduced. Okay. So now I was telling you, that if two circles are given directly, now you cannot visualize, na? You cannot visualize. You have to apply some condition. So for that, okay, सबसे पहले first of all, calculate C1 center and C2 center. Then R1 radius, R2 radius. 4 things you have to do. Then I will tell you what to do. 2, 3, okay, ma'am. And minus 3, minus 9, okay. R1 radius, square root of 2 ka square 4 plus 3 ka square 9 plus 12. So this is 12 plus 4 is 16 plus 9, radius is 5. Okay, perfect. R2 is square root of 9 plus 81 minus 26. So this is 90 minus 26. 90 minus 26 is 64, radius is 8. Okay. So now distance between C1, C2, centers, C1 and C2, distance between them. So C1, C2, calculate. 2 minus minus 3, 5 ka square 25, 3 minus minus 9, 12 ka square 144. So this is 961, square root 169 is 13. Distance between them is 13, right? C1, C2. And R1 plus R2, R1 plus R2, radius 1 plus radius 2, 5 plus 8, 13. What does that mean? That means that this is 13 and this is your 8 and this is your first circle, this is your second circle. So how many common tangent is this in this particular case? 1 transverse and 2 direct. That's why 3 common tangent. Option C is absolutely right. Give me a comment below and let me know whether these type of questions you are getting it or not. Okay. Chalo. Now let us talk about the next question. Again, the number of common tangents only. Okay. So number of common tangents that can be drawn to this and this. Again, center 1. So minus, this is actually minus 6x equals to 0, right? So 3, 0. Center number 2, minus 3, minus 1. Radius 1 will be square root of, okay, so radius is simply 3 only. okay, because the circle passes through origin. R2 will be square root of 9 plus 1 minus 1. So the radius is 3 only. Both the radius are same, R2, R1. Now, distance between C1 and C2 will be square root of 3 minus 3. So 636 plus 1. Okay, so root 37. And R1 plus R2 is equals to 3 plus 3, 6. Clearly, C1, C2 is root 37. Root 37 is just greater than 6. C1, C2 is greater than R1 plus R2 this time, right? C1, C2 is greater than R1 plus R2. Basically, distance between centers is, so this is R1, so this is the circle. This is R2, this is the circle. And this C1, C2 is greater. So, how many tangents is in this case? 4 tangents. 5 so never possible. 5 tangents so we have not seen, na? 4, 3. So, 4 tangents in this case. Okay. All right. Clear? Chalo. Now, let us move on to the new topic, which is chords of a circle. Okay. So, there are 2 types of chord. First is chord of contact. Understand what is chord of contact. What is the definition, meaning of chord of contact? Suppose you have a circle, you have an external point. From the external point, obviously you can draw pair of tangents. And now, this is external point from your drawing, pair of tangent. This is point of tangency. This is also point of tangency, point P. Now, AB is chord of contact. Chord of contact which is formed by point of tangency of 2 tangents which is drawn from external point. This is chord of contact, okay? Now, how to write the equation of chord of contact? You will be surprised to know that chord of contact equation is also given by T is equals to 0. Now, you must be confused. You must be wondering, ma'am, hold on. Chord of contact, that means this chord equation you can draw, you can just write by T is equals to 0, where point P this time is an external point. Okay. So, if a point is given on the circle, then only single tangent can be drawn, and T is equals to 0 will give you what? Tangent to this circle. Okay, ma'am. Cool. But if a point is lying outside the circle, now there is a process. You're drawing 2 tangents, and from these 2 tangents, from the point of contact, you're drawing this. That is chord of contact. Right? This is point. This is chord. This equation can be given by T is equals to 0 also. Okay, this is equation of chord of contact. Let's do one thing. Let's solve a question, then understand whether you have understood it or not. Okay. Tangents are drawn on the circle this at the points where line intersects it. Okay. Tangents are drawn on the circle at the point where the line intersects it. So basically what they are giving, this is actually chord of contact only. This is COC. Okay, x plus 2y is equals to 4. This is the line. Okay. This is the point x1 comma y1 from which you have drawn these 2 tangents. And this is given by T is equals to 0. What are you looking for? This time you're not looking for chord of contact. You're looking for point of intersection of tangent. That means you're looking for this. Now understand one thing. Remember it. Whenever you revise chord of contact, always remember you will not get the direct question. You will not get a point and you will asked that right equation of chord of contact. Never. You will always be asked for the reverse thing. Equation of chord of contact will be given to you and point, external point will be asked from you. And that is where majority of students are not able to think that, okay, I can apply chord of contact equation over here and then I can compare. Let me show you first, then I will talk about it. So this is your circle x square plus y square is equals to 8. Forget about the equation which is given to you. Just tell me that if external point x1 comma y1 is given to you, then can you write equation of chord of contact for me? So yes, so write. So x, ma'am, t is equals to 0. You know x, x1 plus y, y1 is equals to 8. This is your chord of contact equation. Now, as per the question, they have also given chord of contact, right? X plus 2y is equals to 4. Now, this is also chord of contact. Now, you have to compare. How will you compare? There are multiple ways. You can just make the constant part equal, so multiplied by 2. So, 2x plus 4y is equals to 8. Now, these two things should be same. So, 2x and x1. If you compare, x1 is equals to 2. y1 and 4y, so y1 is equals to 4. 2 comma 4. 2 comma 4 is the point of intersection because x1 comma y1. So 2 comma 4 is final answer. Very, very important because right now you're understanding, but when the question arises, you won't be able to think, okay, I have to do this. Okay. Chalo. Next question. Tangents are drawn to the circle at the points where it meets the circle this. Okay. Understand. There is a circle. Tangents are drawn to this circle, but where? At the point where it meets the circle, another circle. So there are two circles basically which are meeting at 2 points. And what we are doing is the first circle, this is x square plus y square is equals to 12. Na? So tangents we are drawing at this circle. Okay. At this point and this point. So first circle, so this is what it is. Now point of intersection x1 comma y1. Okay. Now I will tell you the trick. Whenever two circles, trick time. Whenever two circles are given, okay, then if you want to find the common chord, see, two circles are there, na? Then common chord is there. Basically, the chord of contact is nothing but the common chord between them, right? So, common chord you will get by just subtracting first circle minus second circle. Okay. So, if you have two circles, then the chord of contact is equals to common chord of both the circle, common chord, right? And this you will get just by subtracting these two circles. So, x square plus y square is equals to minus 12, na? So, minus 12, basically we are subtracting, okay? Just subtract it. So, it will become what? X square plus y square is getting cancelled out, right? Then this is 5x minus 3y. Then it is what? Is equals to 12 minus 2, right? So, 12 minus 2 is 10. So, this is your common chord of contact. Now, so irrelevant now because what you're drawing tangent to the circle number 1. X square plus y square is equals to 12. Now, t is equals to 0 will also give you COC. So, x1 plus y1 is equals to 12, right? Okay. So, now you just have to compare, right? So, 5x minus 3y equals to 10. Tell me how will you compare? So, now x is same, x1 by 5, ma'am, is equals to y1 upon minus 3 is equals to 12 upon 10. So, x1 is your 5, 2s are 10, 6. x1 is 6, y1 is your, so this is minus 36 by 10 or minus 18 by 5. This is your y1. So, this is your, again, point of intersection of the tangents. Okay. So, 6 comma 18 by 5 is the answer. Hold on. 5x minus 3y, correct. And 12 minus 2, 10. So, it should be negative, right? 5x minus 3y is equals to 10 and chord of contact will be x1 plus y1 equals to 12. So 12 by 10, perfect. So k is minus 18 by 5. Yes, k is minus 18 by 5. Correct. Okay. Yeah. Now let us move on to the next problem, similar type of problem. Equation of the chord of contact. If the tangent are drawn from this point, now they are asking you the easier question. Point is given, the external point 5, -3, and they are asking you the chord of contact, basically this. Simple. This is x1, y1, right? So x square plus y square is equals to 10, x1 plus y, y1 equals to 10. 5x minus 3y is equals to 10. Option A is absolutely right for this question. Okay, this is a very, very easy question. Okay, now I have already told you now that we have two types of chords basically. First one we have already studied, that is chord of contact, t is equals to 0. Now second, equation of chord whose midpoint is given. Okay, suppose you have a circle and there is a chord whose only midpoint is given, then can you just write the equation of chord? Yes, definitely. Okay, so equation of chord whose midpoint is given by t is equals to s1. What is t? So t, so you are doing it, t is equals to 0 you are doing it, but this time t is equals to s1. So t is same thing, x1, y1, right? So again that circle will be there. With the help of circle you have to write t. This will be done for you. S1 is you have to put that point in the circle. Okay, let us do one question so that you understand it better. Find the equation of the chord which is bisected at -2, 4. So basically you have a circle, you have a chord whose midpoint is given. Bisected means what? Midpoint. Now t is equals to s1. T from here, x1, so x minus 2 plus y1. So y into 4 minus, now 6x can be written as 3 into 2x. 3x plus x1 plus 5 into 2, 2y, y plus y1. So y plus 4 minus 9 equals to s1. Now you have to just put that point in the right hand side, s1. Don't forget 4. Okay, minus 2 square is 4 plus 16 plus 12 plus 40 minus 9. Minus 9 cancel and you just have to solve it. So this is going to become minus 2x minus 3x. So this is minus 5x. Okay, 4y and 5y. So plus 9y. So clearly 3x plus 2y is wrong. 2x plus y is also wrong. Minus 5x plus 9y, na? This is also wrong. D is correct till now. Now let us solve it further. So y and x are sorted, no? Now you need constant term. This is plus 6 and plus 20. So plus 26 equals to 12 plus 4, 16 plus 16, 32 plus 40. So 4, 5, 6, 7, 72 minus 26 equals to okay, 16 plus 16, 32, 32 plus 40, 72, 72 and from here plus 6 and 5 4s are 20. 72 minus 26 is 46, right? 5 minus 6, yes, 46. So yes, option D is absolutely matching. Okay, all right, chalo. Now let us move on to the next topic, which is family of circles. All right, so family of circles, before starting it, I just want to remind you the family of lines. Family of lines. So suppose you have two lines and you have a single point of intersection from these two lines, right? So now, point of intersection, there will be infinitely many lines whose equation is given by L1 plus lambda L2 equals to 0. This is your L1, this is your L2. This is family of lines. In family of circles, a similar type of thing will happen. So a circle and a line will be there, or two circles will be there. And by the point of intersection of circle and a line, there will be again infinitely many circle will pass, right? So equation will be given by, so let me just tell you, suppose you are having a line and a circle, okay? So this is your circle and this is your line. Now point of intersection is A and B. Through these points A and B, there will be infinite circles whose equation will be given by circle plus lambda times line equals to 0. Let's have a look at the example. Any circle passing through intersection point of this circle and line is of the form this. So this is your circle plus lambda times line equals to 0. Now they should give, if they are asking you any question, so a line and a circle will be given to you, but on top of it, they should give one condition so that you can find the value of lambda and give the specific circle which they are looking for. Okay. All right. So let us just do one question on it. Okay. Okay. Perfect. So now equation of the circle passing through point of intersection of line and circle, and it passes through 3, 4 again. So it will be given by s plus lambda L equals to 0. Circle equation is x square plus y square minus 9 plus lambda times x plus y minus 1 equals to 0. Now this circle, this is the equation of my circle, passes through 3, 4. So 3, 4 will definitely satisfy. 3 square is 9 plus 4 square is 16 minus 9 plus lambda times 3 plus 4 minus 1 equals to 0. So 16 plus lambda, this is 4 plus 2, 8 equals to 0. Sorry, 6, right? Yes. So this is going to become lambda is minus 16 by 6. So this is going to be 3 and 8. So lambda is minus 8 by 3. Now you put the value of lambda over here to get your circle. So now your circle will become x square plus y square minus 9 minus, sorry, not minus, plus 8 by 3 because, sorry, minus 8 by 3, right? And this is going to become your line, which is x plus y minus 1 equals to 0. So this, if you solve it, you will get equation of your required circle, right? So finally, you will get 3x square plus 3y square minus 27 minus 8x minus 8y. Okay. And plus 8 equals to 0. So 3x square plus 3y square, correct, minus 8x minus 8y, and you are having minus 27 plus 8 will give you minus 19 equals to 0. Okay, clear? So this is how your questions are done. Now the next type, when two circles are given to you, and there will be obviously infinite circles which will pass through the point of intersection of these two circles, and the equation is given by s1 plus lambda times s2 equals to 0. Okay. But in here, lambda cannot be equals to minus 1 because whenever lambda is minus 1, this will give you s1 minus s2 equals to 0. Remember, we have already done this question. When we are subtracting equations of circle, we are getting a common chord of those two circles, right? So, there's a special case. When you subtract two circles, now you will not get the equation of circle. You will get equation of line passing through point of intersection. So, special case, S1 minus S2 gives you equation of common chord of the circle, right? Otherwise, this case is S1 plus lambda times S2. So, suppose circle number 1 is given and circle number 2 is given. And any circle passing through intersection of both the circle is given by S1 plus lambda times S2. That's it, equals to 0. Okay. All right. Let's just do one question on this as well. Two circles are there. Equation of circle passing through point of intersection and also passing through 1, 1. Okay. Again, S1 lambda times S2 equals to 0. Now 1 comma 1 you have to satisfy. So 1 plus 1 minus 6 plus lambda 1 plus 1 minus 6 plus 8 equals to 0. So this is 2 minus 6, so minus 4 plus lambda. This is 2 plus 2, 4 equals to 0. So lambda is coming out as 1. The moment you put lambda equals to 1, you will get 2x square. Put lambda equals to 1. 2x square plus 2y square. Okay. Then you are having minus 6x minus 6 and plus 8 equals to 0. So x square plus y square minus 3x, this is plus 2, plus 1 equals to 0. So clearly option B is matching with our answer. Okay. Easy peasy, right? Not a very, very tough question. Now, the equation of circle passing through the point 1, 1. Okay, so this is definitely a homework question. Definitely. Because again, the same thing, two circles are given. 1, so S1 plus lambda times S2. You satisfy lambda. Okay. So satisfy 1, 1, get the value of lambda, put the value of lambda and you will get the equation. Okay. Do let me know in the comment section. Okay. All right. Now this something is a tricky question. The equation of circle whose diameter is equation of my circle, right? Equation of circle C. This is S1, this is S2, right? Equation of circle whose diameter. So basically, they are talking about my circle's diameter, which is like given in option A, B, C, D. So equation of circle whose diameter is common chord of these two circles. Okay. Diameter of my circle, can I calculate? Diameter of C, S1 minus S2 equals to 0, right? So yes, 3x gone, 2y minus 2y and minus 1 equals to 0. This is your equation of diameter. Basically, we have subtracted the circle. Okay. So what is happening? The equation of circle whose diameter is the common chord. What is happening? There are two circles. Okay. And common chord is this. Now, my circle, diameter is actually this, will look like this only. Right? Okay. So my circle actually is passing through point of intersection of either these two circles or any one of the circle and a line. So you can write it as S1 plus lambda times S2 equals to 0. Then also it will be fine. Or S1 plus lambda L is equals to 0, where L is the diameter, right? This both are fine. So we'll take this. Line is easier, no? Circle 1, any circle you can take out of both. X square plus y square plus 3x plus 2y plus 1 plus lambda times, now diameter is 2y plus 1. Hold on. This circle. Now you must be wondering, ma'am, okay, but where will you get the value of lambda? Because no condition is given after this. Yes, there is a hidden condition which is given. Can you calculate center of this whole circle? So center of this whole circle you can calculate by reversing the coefficient of x and dividing it by 2, reversing the sign. So 3x. There is no x over here, only 3x. So minus 3 by 2 is the center, comma. This is 2. Now coefficient of y. What is coefficient of y? So ma'am, 2 plus 2 lambda. So now you have to take half of it. So 1 plus lambda and take minus sign also, minus of 1 plus lambda. Okay. So this is your center of the circle. Now center of the circle lies on, tell me, diameter of the circle. So basically the y coordinate of the diameter is half, actually minus half. y is minus half. Y is minus half is y coordinate of the diameter. So y coordinate should be minus half. So, right, so minus of lambda plus 1 will be minus half. Minus minus cancel. Lambda plus 1 will give you half. Lambda will be minus half. So lambda minus half, now you got it. Now just plug in the value. X square plus y square plus 3x. Okay. Plus 3x. Then we are having yes, x square plus y square plus 3x plus 2y plus 1. Lambda is minus half and equation of diameter 2y plus 1 equals to 0. Just solve it. X square plus y square plus 3x as it is, 2y and minus y. So plus y. 1 minus half plus 1 by 2 equals to 0. So now you can check the answer. Okay. Yes. So I guess 2x, if you take LCM, 2x square, 2y square plus 6x plus 2y plus 1. 6x plus 2y plus 1, option D. Absolutely right. Okay. All right. Yes. Now, so first two cases we have seen. Now the third case. Third case is very easy. If 2 points are given to you, right? 2 points. Straight away 2 points. And you have to write the equation of circle passing through these 2 points. And one more condition is obviously given. See, the condition will also come into the picture, that equation of circle passing through 3 points. Now, if you assume the equation x square plus y square plus 2gx plus 2fy plus c is equals to 0, put one by one all the points in it, you will get 3 equations and 3 unknown. The solving will be much difficult for you. Okay. Family of circles will make it easy. So suppose there is a question which says that a circle is passing through 3 points. Okay. So what we will do is, we will first think about only 2 points. So family of circles passing through 2 given points is given by, now how to write? So first of all, do you remember diametric form? Just write the equation of that circle with the help of diametric form. X minus x1, x minus x2 plus y minus y1, y minus y2. Circle equation is done, plus lambda times. Now equation of this line L passing through these 2 points also you can write equals to 0. So this is the circle which is passing through 2 given points. Now there is third point as well. So you can just satisfy third point to get the value of lambda. Done. Okay. So yeah, these things can be done. For example, this, any circle passing through 1, 1 and 2, 2. So here diametric form, x minus 1, x minus 2, y minus 1, y minus 2. This is diametric form plus lambda times. Now 1, 1, 2, 2, say there will be a equation of line which you can write 2-point form, y equals to x. Now third condition should be given so that value of lambda can be formed. Here, equation of circle passing through these 2 points, okay, and having center is on the line. Okay, so first of all, equation of circle passing through 4, 1 and 6, 5. Okay, so x minus 4, x minus 6 plus y minus 1, y minus 5. This is again diametric form plus lambda times. Now equation of the line, y minus 1, x minus 4 and slope. Now slope, right? 5 minus 1, 4 upon 6 minus 4 is 2. This is 2-point form of this line. So this is y minus 1 is equals to 2x minus 8. Y is equals to 2x minus 7. 2x, y is equals to 2x minus 7 will be y minus 2x plus 7. Now the center of this circle lies on the given line, right? Can you calculate center of this circle? So ma'am, x square minus 10x plus 24 plus y square minus 6y plus 5 plus lambda times y minus 2x plus 7 equals to 0. Okay. So now the equation is like this. Now center of this circle we can calculate, right? Center. So this and this. These two will form coefficient of x. Tell me. Coefficient of x will be -10 minus 2 lambda. Coefficient of y will be, tell me. So ma'am, it will be -5 minus 6y, right? And plus lambda. -6 plus lambda. Correct or not? Tell me. Yes? Okay. Now, center of the circle. You know how to calculate, right? Let me just write it over here. Center of the circle. Negative of half of coefficient of x. So 5 plus lambda, comma. This is lambda minus 6, right? Yes or no? -6, and this is minus or plus. Lambda minus 6. So this will become okay. So lambda minus 6, no? 6 minus lambda by 2. Yes. Now this center should lie on this circle, right? So can we satisfy? So 5 plus lambda and 6 minus lambda by 2, we will satisfy in 4x plus y equal to 16. So x will be 5 plus lambda, correct. Y will be 6 minus lambda by 2 equals to 16. 20 plus 4 lambda plus 3 minus lambda by 2 equals to 16. So 23 plus 4 to the 8, 7 lambda by 2 equals to 16. So 4, 7 is equals to 7 lambda by 2. Lambda is coming out as half. The moment you get your lambda, now so you are done, na? Just put this value of lambda over here, get the equation. So lambda, if it is half, right? So you will get lambda is half, na? So just give one coefficient. So lambda is half. The coefficient of x will be -10 -1. Lambda is half, kya? Hold on. Sorry, lambda is 2, right? Lambda is 2 from here. Yes. Lambda is 2, correct? So if lambda is 2, 23, hold on, 23, sorry. 23 minus, so 7 is equals to -7 lambda by 2. So lambda is coming out as -2, correct. Now it's fine. Lambda is -2, right? The moment you put -2, your coefficient of x will become -10 plus 4. -10 plus 4 -6. And this is -2, so -8. -6 and -8 is matching with either C or D. So constant term you have to calculate now. So 24 plus 5 is 29. 29 plus 7 lambda. So 29 minus 14 is 29 minus 14 is 15. So 15, option D is absolutely right. Okay, done. All right. Now let us talk about the fourth and the last format, where a tangent line is given to you and point of tangency is also given to you. Tangent line, family of circles, tangent to a given line is given to you and at a given point is also. So there will be again, see, how many circles can we create or can we draw where a specific point is given and the condition is that the line should be tangent at that point. So many, right? So what we will do is how to write, so x1, y1 is point of tangency, okay? So suppose if I tell x1, y1 is the center of a circle, how will you write? So you will write, ma'am, x1 minus x1, x minus x1 square plus y minus y1 square. But radius we don't know. Yes. So here we have to write the equation of point circle. Point circle means we don't know the radius basically, or radius is 0. If radius is 0, then x minus x1 square plus y minus y1 square, that's it, equals to 0, right? So this is point circle plus lambda times equation of tangent equals to 0. That's it, right? So in this case, point circle plus lambda L is equals to 0, okay? So yes, now for example, any circle touching this line at this point is of the form, now 1 comma minus 2, write the equation of circle, x minus 1 whole square, y plus 2 whole square plus lambda times this line. That's it. Let's just do the question so that you understand what I'm trying to say. Find the equation of circle passing through the point this and touching the line. At what point, that we will see later. This line is not visible now. X plus 2y minus 1 equals to 0, right? So first of all, equation of circle passing through this point. So this point right now, let's talk about it later, but this is the line at the point. So basically line is given and point is 3 comma minus 1. First of all, x minus 3 whole square plus y plus 1 whole square plus lambda times x plus 2y minus 1 equals to 0. Now 2 comma 1 satisfy. If you just satisfy 2 in here, 2 comma 1, because it passes through 2 comma 1. 2 if you put the 1 if you put 4 plus lambda times 2 comma 1, 2 plus 2 minus 1 equals to 0. 5 plus lambda times 3 equals to 0. Lambda is coming out as minus 5 by 3. Now you put lambda minus 5 by 3, you will get your answer. Okay. So if you put, let me just tell you that which is correct answer. First option you will get. Option A you will get the moment you put lambda equals to minus 5 by 3 as the value of lambda. Okay. This is 3. Minus 5 by 3. Okay. All right. Now the last topic of the day, which is orthogonality of two circles. Okay. So in orthogonality of two circles, suppose these are those two circles, circle number 1, circle number 2. Perfect. Now, yes. So now these are the two circles. If I take this point on the circle and draw a tangent, and on this point, on the point of intersection, I draw another tangent on the second circle. Now, if they intersect each other at 90 degree, that means angle between tangents at the point of intersection is 90 degree. Then we will call it as orthogonal circles, and also both the angles should be 90 degree. So these two will be orthogonal circles, right? So now what is the condition of orthogonality? So now there will be two types. First, when the circles are given in this form, x minus x1 whole square plus y minus y1 whole square is equals to r1 square. Second will be x minus x naught whole square plus y minus y naught whole square equals to r2 square. Right? If this format is given, then have a look at this diagram. This is your center number 1, center number 2. Join these two centers. Okay. Now, this is the point of intersection. Tangent number 1 you can see, tangent number 2 you can see, and obviously for orthogonality, line should be perpendicular. So now Pythagoras theorem will come into the picture, because clearly right angle triangle is getting formed. This is your R1, this is your R2. So now using Pythagoras theorem, R1 square plus R2 square is equals to D, which is distance between centers ka square. So if this is equal, if this is satisfying, this condition is there, so it will intersect orthogonally, right? And now if the circles are given in this form, x square plus y square plus 2g1x plus 2f1y plus c1 equals to 0. x square plus y square plus 2g2x plus 2f2 y plus c2 equals to 0. This is your second circle, right? Now, 2g1, g2, see, 2g1, g2 plus f1, f2 plus, equals to c1 plus c2 will give you the condition of orthogonality. Okay, all right. So, two different, like, whatever the form is given to you, you can apply that condition. There are two conditions basically. Show that, now as per the, let's apply it, then understand. Show that these two circles are orthogonal. Okay. So, 2, now G1 is what? Minus 4. G2 is what? Minus 1. 2G1, G2 plus 2F1. F1 is what? 3. F2 is minus 5 by 2. Is equals to C1 plus C2. We need to check. 8, 2 cancel, minus 15 equals to 6 minus 13 will be 7. Right? And 8 minus 15 is, so this is again minus 7. Minus 7 is coming out as minus 7. So yes, these two circles cut each other orthogonally, definitely. Okay. Now the last question of the day, which is talking about, again, two circles are given and it is given that they intersect orthogonally. We need to figure out the value of k. Again, same condition, 2 times G1. So G1 is 2. G2 is 0. Right? Because coefficient of x is not given. 2 G1, G2 plus 2 F1. From here, F1 is k and F2 is also k. Okay. Is equals to C1 plus C2. Okay. So 0 plus 2k square is equals to 6 plus k. 2k square minus k minus 6 equals to 0. Now 6 2s are 12. So 3 and 4. 2k square minus 4k plus 3k minus 6 equals to 0. Let's take 2k common. K minus 2 plus 3 common. K minus 2. So k is equals to 2 comma minus 3 by 2. 2 comma minus by 2 is matching with option A clearly. So option A is absolutely right. Okay. Now, a few things which I would like to tell you. Number one, you have to comment below. All the homework questions you have to reply. Okay. So comment all the answers of homework question. Okay. That is one thing. If I have made any mistake in the, like any calculation mistake, you can mention that. Okay. I will reply it to you. Okay. You can ask your doubts as well in the comment section. Number two, if you're looking for the PDF, link is given in the description box, Jungle Book. I will update this PDF right away. Number two. Number three, if you're having still any doubts, you can just ping me on my Telegram channel, t.me/Namrata 𝐤𝐿. Okay. And if you're looking for JEE Main PYQs, offline books, basically the physical books, you can just right away buy Tatva series, and using Tatva series, you can actually solve as many PYQs as possible from 2022 and 2023. Okay. And what should be my next chapter? Do comment, and whichever chapter gets maximum likes, I will take that chapter in the next video. Okay. This is me, Namrata, signing off.